Hello, Christine. Can you hear me?
Hi, Yang. I can hear you.
Great, great. Yeah, I've just got last minute panic email from Ravi last night. Well, this morning, 3 hours ago, and he said, "Can I join?" Because he know I'm on holiday, right? And I thought so. We went through the slide before, and then, but yeah, just in case you need help.
Okay, no problem. Thanks, Yang.
No problem. It's been pretty late in your place now.
Yeah, 3:43 a.m.
Yeah, I mean, yeah, it's a
Either
tough,
really early or really late.
yeah, tough work for you.
Yeah. That's okay. I'll be done by like 9:45 this morning. So
All right. I hope to get to see you some point soon.
no. Okay, I'll get you added to the session. His session doesn't start for another hour, so
You mean Ravis?
yeah.
It said 8:45. Oh, UTC. Oh gosh.
Yeah. So there's a few keynotes that'll be happening that are pre-recorded, and then in 1 hour you'll be able to
Okay.
join us on.
Okay. All right. Okay. So that's an hour from now.
Yep.
Got it. Got it. All right. I will go to another meeting instead. Then I'll come back.
Okay.
All right.
Bye.
All right. Thanks. Bye.
Hi, Ravi. You can share your screen whenever you're ready.
Okay, sure, Christine. Okay, just let me know when you can see it.
Yep, I can see it.
Okay, sounds good. Let me turn on the cameras as well.
Yeah, great.
Okay.
Okay, I can see you. We just have about 1 more minute and then we can get started.
Sure.
I just pinged Yang too, so
Okay.
make sure he gets in here. Okay, you can go ahead and get started, and I'll just go on mute.
Okay. All right. Thanks, Christine. So my name is Ravi Kumar Chakravarti. I lead the open source stack development at Xilinx. And lately, my focus has been more around AI acceleration stacks and automotive solutions, also targeting autonomous driving. So today in this presentation, I will be discussing a vision control unit that we designed and developed working with Linaro and AutoCore. My partner Yang also, I think he's in the meeting today. We worked together to build a solution. So before we talk about the solution, I just want to give a quick background on why this project started and what is the intent of this project. So going to a quick introduction, Ware Foundation has been initiating and growing a lot of the AutoWare projects. And this has been adopted by many companies around the world and over 20 countries. And has been used in a variety of autonomous driving applications like robocars, automatic conveyors, last mile delivery vehicles. So AutoCore is one of the key members of AutoWare Foundation that has been really prophesizing this use of AutoWare stack, and they've been able to put together end-to-end heterogeneous compute platform. So this vision control unit that we are talking about today is part of that overall stack. So if you look at the bottom left side, there's a diagram illustrating the components of the autonomous driving stack. So there's a sensing module, there's a computing module, and the actuation module. The sensing module uses all kinds of cameras, LiDAR, radar, all kinds of peripherals to capture data for the robocars. And the compute module uses the data to make intelligent decisions for the car. And the actuation module is really trying to maneuver the car based on the decisions generated from the computing module. So the presentation that we are doing is focused around sensing and computing modules that we have designed and developed. So to give you a big picture again, so there is a vision control unit and a perception control unit that is part of the autonomous driving car. The vision control unit uses cameras to make intelligent decisions for the car, and it does all kinds of AI processing and all of that to be able to make those decisions. The perception control unit relies on radar, LiDAR information, and together the data from the two is combined to make intelligent decisions and help maneuver the car. So AutoCore has been one of the first to use 96 boards to drive the mobility platform. Also built the first AutoWare reference platform and the first open source design and developed the first open source SLAM algorithms on the platforms. So this figure shows the various components or systems of the robocars. And on the left side is the perception control unit. On the right side is a vision control unit. The perception control unit has connectivity to radar, LiDAR, IMS, GPS sensors. On the right side, the vision control unit is connected to 6 cameras. And the vision and the perception control unit talk to each other over Ethernet. And we'll discuss more in details on how they talk to each other, but essentially the data gets passed between each other and intelligent decisions are made on the car. So the whole setup has three different units of computation. We're calling it P1, P2, P3. The camera capture unit or the vision control unit does CNN processing for the overall car, robocars. It does camera perception. The PCU does localization and sensor fusion of the images. And together they are combined and they're sent to the P3 computation unit that actually makes vehicle control decisions for the stack. In addition, we also have connectivity here on the simulators that can, so you can essentially develop algorithms on the simulator even before realizing this on the real platform. So the overall solution essentially has PCU, 2 PCUs and 1 vision control unit. So let's talk about vision control unit. So essentially vision control unit uses cameras to sense the surrounding of the car and then make intelligent decisions. So before we get to the details, so let's talk about requirements. So the vision control unit supports, needs to support 4 side cameras, and the side cameras are essentially needed to get a surround view of the car. And typically the solutions that they target is, or the application they target is around the self-parking and things like that nature. And 2 front-facing cameras that capture the front view of the car, and they're used for object detection and classification. One of the requirements for us is to use open source stack. And this is predominantly because most of the automotive OEMs, they want, at least for the evaluation stack, they want open source stacks to be used. And for production, they want it to be safety certified. So most of the open source stacks are not really safety compliant. But if you look here, we are pretty much doing all of this on an open source stack. And we're using V4L for capture pipeline. We're using a bunch of peripheral drivers, open source drivers, Yocto, Linux kernel, embedded stack. We also have designed and developed open source AI stack called XTA. We'll talk about it later. And the ROS v2 middleware stack for communication between the processors, processing subsystems. Performance requirements around 8 to 10 FPS, depending on the applications we are targeting. And like any automotive application, we are required to support the over-the-air update. In addition, we are also required to support update of real runtime parameters for AI training. So vision control unit, essentially the first thing that comes up in the vision control unit is a camera. The camera is actually a sensor. It has an ISP and a serializer. And the captured image is serialized and sent to the vision mezzanine board, the designed and developed by Linaro. And this board actually deserializes the data and sends it over to the Ultra 96 board. And the Ultra 96 board actually DMAs the data to different regions of the memory. So we are actually storing this data as DMA buffers. And this will be used in the next stages of the pipeline processing. The solution supports up to 8 cameras. In this picture, we're showing 4 links, but it can support up to 8 cameras. So the image processing pipeline uses the data captured from the DMA buffers, but it needs processing capability to compute to do a lot of computation on this captured image. So if you look at it, and the lowest end here, we have processing backends from Xilinx MP SoCs. So PL is the FPGA fabric that supports compute acceleration. The APUs and RPUs are the A53s and R5s that we have in the Xilinx MP SoC, and the GPUs are the Mali core GPUs. The stack above it is the Linux based stack. We have the V4L2 for capture. We have a heterogeneous scheduler designed and developed as a part of the XDA AI engine stack. And we'll talk about in the next few slides and how the heterogeneous scheduling can actually slice and dice a AI problem and orchestrate it across the different backend cores. The OpenGLES is predominantly used to accelerate the image processing on the GPU. If you look at the application stack, it takes the data from the DMA buffs. And let's say you have 4 cameras, you capture images for the 4 cameras, it does a composition of the image, it downscales the image. And that's because the AI stacks under a certain resolution. And then it normalizes the data and then it processes the backend. So when it processes the backend, it does AIE or the YOLO V3 Lite or the object classification. And the result is it detects or it generates the bounding box for the region of interest. Or let's say if you are interested in detecting a car, it kind of draws a bounding box around it, or it generates the coordinates for the bounding box. And that is passed to a GPU pipeline. The GPU pipeline takes that and over the ROS interface sends the data to the PCU. The PCU is a perception control unit. It takes the data from VCU and then it uses a sensor fusion data and it makes more intelligent decisions. So XDA is the stack that we had designed for AI engine acceleration. And one of the requirements that we had for doing AI acceleration is to be able to use all the heterogeneous hardware backends of the Xilinx MPSoC. And we are not aware of any stack that can use all the compute capabilities of the MPSoC. And that's one of the reasons why we came up with the stack. But there's one stack that we came across that was close enough to as a starting point, and that was the TVM VTA stack. We extended the stack to support heterogeneous compute. So, and not only heterogeneous compute, but also to be able to support pipelining and parallelism. If I had an AI graph and I want to schedule it across every part of the backend here, like FPGA, A cores, R cores, and the GPU, I need a framework that can splice and dice the graph and schedule it. And that was a key requirement to optimize performance. And I also had to do it in a parallelized fashion. So many of those frameworks, they kind of execute on one core, they send it to the next core. So we really wanted to pipeline it and parallelize it. So we had to extend that capability. We also wanted to make it configurable in the sense that if I didn't want to use like a R core, and if I wanted to use the other 3 cores, I wanted to be the architecture or the framework to give me the knobs to be able to do that, so that I can automatically orchestrate these graphs on these backends. In addition, we also wanted to be able to scale the processors in the sense that if I had a small FPGA like Ultra 96 board, I probably instantiate 1 gem core, but if I had a larger FPGA, I could scale the performance by instantiating multiple gem cores. And for that, we wanted to make it very simple for the user to configure and configure these cores so that the stack automatically can splice the graph and schedule it to various backends. So one other key requirement for this AI framework is to be able to auto-tune. When you have multiple backends, it really requires an expert level person to be able to splice the graph and orchestrate it. It is not a scalable solution, and so we needed something that can be auto-tuned. Auto-tuning is a concept that's popular at an operator level, supporting a specific backend, but what we are supporting here is a graph level auto-tuning or subgraph level auto-tuning that can be orchestrated across multiple hardware backend cores. So essentially, it can splice the graph in the most optimal fashion, and that can be scheduled in various backends for best performance. So if you want to understand more about how we do this, we have a presentation, the IEEE conferences next month. We have a paper accepted in it, so you're free to listen into it. So at a nutshell, the way the AI acceleration works is it uses a high-level model like TensorFlow PyTorch. It takes a graph The XDA has a compiler that parses the graph, does a bunch of compute optimizations, and then it converts it into an intermediate representation. So we rely on TVM for some of the stuff. And then once it does the intermediate representation, we do a bunch of schedule optimizations, especially around heterogeneity. And that is where we are talking about the packing and splitting of graphs. So if you think of a big graph, we really want to splice it into multiple backends so that it can be pipeline and accelerated and parallelized. So here, if you look at it, we are showing examples of FPGA, GPU, and ARM instructions. So the graph is essentially split into 3 different backends. And we are generating binaries for each one of these backends. Now, these backends binaries are then going to be used by a runtime stack, the JIT compiler we talked about earlier that can execute the graphs. So this example shows how different images can be processed in a pipeline and parallel fashion. So essentially we break it down into 3 different stages: pre-processing and the processing of image itself and the post-processing. And if you look at the right side, we're using all the heterogeneous cores, not only the backends, but all the cores that's available. From the GPUs, the A53s have four cores. We're using all the 4 cores. The FPGA and the R5s have 2 cores. We're using all the cores. And part of the reason we are doing this is we want to kind of load balance it across all the processors to be able to take best advantage of it. And also want to make sure that we're not fully loading any CPU or the processing backend. So we could essentially throw more compute capabilities at it for future. So this is some performance data here. We are trying to get the best performance by trying to split the graph in a very optimal fashion. Obviously, compared to the existing frameworks that actually schedule the processing in a more sequential fashion, doing it in a pipeline parallel process is obviously going to need better performance, and we are seeing very good performance results from this stack. Over-the-air update. So Xilinx has had a flavor of Linux called Better Linux that we have been supporting for many years now. And that stack essentially supports runtime software component updates. That's Better Linux. It's a flavor of Linux that we have been using for some time now. What we are doing is we are piggybacking on top of that infrastructure to be able to support update of boot components, update of runtime components, kernels, drivers, even FPGA designs and hardware designs. And in addition to that, we are also trying to support the ability to be able to train, ability to update the training parameters on the fly. So it's actually a key requirement for, because as you keep training and getting better optimized parameters, you want to update it on the fly. So this is actually showing a demo of the solution we had put together. The solution actually uses 4 cameras, and each camera is pointing to a certain region which has a car. And the top left is actually a video clip, and the bottom 2 are static images. The right top is actually a non-car image. So this actually captures the image, and we actually run YOLO on each one of these camera images. So you could configure the pipeline many different ways. You could do a surround view of the 4 images and then apply YOLO. In this case, we are applying YOLO on each one of them. We are seeing that the stack is able to scale up to those different requirements. So just to conclude, we had a very good collaboration with Linaro, Autocore, and Xilinx to be able to put together this automotive reference platform. Also, I think this is one of the, we have done a very good job, I think, in pulling together open source components. And all the work that we have done, we have upstream some of it, and we are intending to upstream all of it in a phased approach. So that's been a very good collaboration, but there's also been a lot of good collaboration with AutoWare Foundation 96 boards, and also the Autocore Incorporation on the other parts of the autonomous driving stack, especially on the perception control unit and actuation control logic. This solution actually uses Ultra 96 board, which is a really low-end board, low-cost board, and also low-end board. But we are able to see good performance with that low-end FPGAs. And not only that, I believe that we have enough processing capability, especially in the R5 cores. There's enough processing power. We haven't used much of the GPUs as well. And these can be used to extend the capabilities of the stack for other autonomous driving capabilities like localization and such. So that concludes the presentations. I'm ready to take on any questions. Okay, so let me see. So what are the main differences between the AutoWare and Apollo? Apollo, it's driven by Baidu and AutoWare as from AutoWare Foundation. Apollo stack, although they claim that it's open source, I don't believe every aspect of their Apollo stack is open source, and AutoWare is completely end-to-end open source. AutoWare stack targets certain range of applications, more like city driving kind of applications. I hope that answers the question. Okay, I think Yang has already answered those questions here. Okay, any other questions?
Hi, Ravi, can you hear me?
Yes, I can hear you.
Yeah, I think there's a lot. There's a lot of content that we condensed into a couple of slides. So I think people are going to need time to digest. So just probably question for Christine. So those slides, a version of that will be available on the website, right?
Yes, on the SCAD event site, and then as well as the resource page.
Okay, yeah. So once the review is happy with that, I think that people will have more time to look into, because that there's a lot of content we actually jammed into a few slides here.
Yeah.
Okay. So I see a question regarding XTA. Has it been open source? We have been open sourcing in phases. So there's been upstream actually. Some of there's been some parts of the logic that's already been upstream, but some of the logic related to scheduling and hardware abstraction layers and graph splitting has not yet been upstream. So we will be doing it over time. So XTA is both TVM and VTA. We are hoping to contribute. So we already have contributed some things to a TVM, but we are also hoping to add more. The thing is, the amount of changes that we have made to support heterogeneity is quite a bit, and we'll have to work with the maintainers there to see how we can upstream it.
Just another note, we have a Slack channel for this session. If anyone comes up with any questions later, once they have more time to think about it, they can reach you in the Slack.
Okay, sure. So this is the alternate 6 port from AvNet that has the Xilinx MPSoCs. So the cameras that were used were the on-semi cameras, right? And these are the GMSL cameras that were used in the setup. Okay, so the next question is, was AI the only use case implemented, or was navigation also implemented? So AI, and then of course, we are also doing image surround vision. We're doing a bunch of scaling and other image processing on the GPU cores. And like I mentioned, we want to extend it to more capabilities like localization and stuff. So today that's done on the PCU, but we would like to do that on the MPSoCs. Do you rely on OpenCL for GPUs? So the Mali is a Mali 400 GPU cores. We do not use open, so we don't use OpenCL here. It's just pretty much OpenGLES. All the GLES libraries for doing the rendering.
Okay, we've come to the end of the time slot for the session. So I've just added the Slack link that'll take them directly to the channel for this session. So if anyone has any more questions, just head over there and you can continue talking.
Sure.
Thank you very much, Ravi.
All right, thanks very much. Take care.
Okay, bye.
Bye.
Hi, Sumit. Whenever you're ready, you can test out sharing your slides if you want to.
Sure, I will start sharing my slides.
Great, I can see your screen. And if you wanted to turn your camera on, I can't see your camera at the moment.
I think you have stopped it, my camera feed. Probably you need to turn it again.
Oh, there we go. Okay, great. I can see you.
Okay, that's great.
Okay, let's just wait 2 more minutes and then we'll get started right at
Sure.
schedule time. Okay, you can go ahead and get started whenever you're ready.
Okay. So, hello everyone. Welcome to this virtual session. In this session, we'll discuss about the firmware encryption feature. As the name suggests, this is related to providing confidentiality protection for a particular device firmware. So as there could be multiple ways in order to achieve it, but they could also come with multiple security flaws or concerns when it comes to a corresponding implementation. So having a properly designed encrypted firmware implementation is the key here. So we'll discuss an appropriate approach in order to achieve firmware encryption in its true sense. A quick introduction about myself. This is Sumit Garg, working as part of support and solutions team Linaro, especially responsible for activities related to security, toolchain, etc. So let's get started about the list of topics I have to cover up today, starting with the security basics and the common terminology that we will use across this session. Then moving on to the firmware encryption feature itself, the assets it tries to protect, and the use cases which are driving the requirements for this feature. Then we will discuss about the firmware encryption challenges to its implementation. These are the list of challenges we will discuss. And the last section will include the implementation details that is currently present in the upstream projects such as TSA and Opti. Now let's start with the security basics just to set up an initial perspective. So overall, security is not a turnkey solution, but it's rather made up of many different components. And I think most of the security software layers involve security in one form or the another. And from system view perspective, there is no such thing like a secure system, but a system could only be marked as a secure enough. So there is always a trade-off between the value of the assets and the value that an attacker would put into compromise those assets. So if the cost of an attack is very much higher than the cost of the value of the assets, then we will say that system is secure enough. And that's why threat modeling techniques becomes very critical here. So one should be aware about the knowledge of the system assets which it's trying to protect and the threats to mitigate them and the security features. So security features, they are considered as the tools in your toolbox, and their application applies to a corresponding threat model as well. So such as firmware encryption feature, which we will discuss today. Now coming on to some of the common terms and the security concepts, I think most of the people attending this session may be aware about these terms in one form or the another. But I will try to introduce them briefly, starting with the confidentiality. So it is about to protect any unauthorized access to the user's assets or any misuse of the user's assets. And second one being the integrity that allows to protect against unauthorized alteration of the system assets. The third one being the authentication, which is there to identify users and validating that if they are validating if what they claim to be. Fourth one being the authorization, which will define the roles of the user. That means what a particular user is allowed to do or not. And lastly, the non-repudiation, which is basically provides the proof of the origin of the firmware system assets, and or in simpler terms, we could say it provides the assurance of the ownership of an asset. Now coming on to the firmware encryption and relating it to the security concepts, which we have discussed before. So firmware encryption in itself provides confidentiality protection and integrity protection. And for confidentiality protection, it uses symmetric encryption techniques. There is another asymmetric techniques as well, which we don't prefer to use for firmware due to the boot time limitation. And for integrity protection for the encrypted blobs, it uses well-known authenticated encryption constructs such as AES, GCM, etc. Now coming on to the assets which firmware encryption tries to protect. The first one being the software IP. The encryption ensures the protection against any unauthorized access or misuse of the software IP. The second one being the device secrets. So encryption allows one to store secrets in the firmware image, although those secrets are very unlikely to be high valued ones. The third one being the implementation details. So encryption ensures to make the life harder for an attacker to develop any exploits or any vulnerabilities that may be present in the firmware. So that's all I had to discuss about the sets. Now moving to the use cases. So the major drivers for this feature are the emerging robustness requirements from the DRM software implementations, which would like to make it even harder to reverse engineer the trusted execution environment, and therefore would like to see the trusted OS as well as trusted applications to not just be signed but encrypted as well. So here we are looking to protect the major TS sets such as DRM software IP and the corresponding implementation details. Moving forward, so this slide demonstrates a simplified version of implementation of a firmware encryption. So in this case, there is a shared secret key, which is known to both the OEM or service provider and the device itself. So the OEM or service provider uses that key to encrypt the firmware image, provisions it into the device flash memory, and during the device boot sequence, the bootloader uses the same key that is provisioned onto the device to decrypt the firmware blob and load it onto the memory and thereby continue the device boot sequence. Now coming on to some of the challenges to this implementation. So the first one being the secret key protection. So how would we like to protect the secret key? And it may vary from one platform to another, depending on the use case and the hardware capabilities that a platform possesses. Such as the key is derived from the device secrets like OTP, like one-time programmable key or such, or key is provisioned into the secure fuses on the device itself. Or the third one could be the key is provisioned into the hardware crypto accelerator. And lastly, it may be provisioned into the platform secure storage, such as non-volatile SRAM, etc. So in order to address this varying requirement, we need to create an abstraction layer in order to retrieve the secret key or the secret key handle, and platform could provide the underlying implementation to hook up as per its choice. Now coming to the second challenge, whether we should use the secret key type be a device unique key or a class-wide common key. So we'll try to discuss the various pros and cons of both key types so we could understand them better. So device unique key, which is also known as the binding secret symmetric key. The major positive for this is it limits the attack surface to per device and also provides protection against the software cloning. The major backdrop is the scalability issue. It becomes increasingly difficult to manage per device unique firmware images for a remote entity. Now the second key type being the class-wide common key, which is also known as shared secret key. The plus point here is it provides a single firmware image that is easy to deploy and update as well. The negative is it provides a comparatively larger attack surface, so it may lead up to class-wide attacks on the devices. So a final thought that came here is how about leveraging the benefits of both the key types. We will explore this option in the upcoming slides. Now, discussing this scenario, which uses both of the key types, such as SSK and the BSSK. In this case, the OEM or service provider only possesses the SSK key, which it uses to encrypt the firmware image and provision it on the device flash memory. And then during the first boot sequence, the bootloader, which has access to both the key types, uses SSK to decrypt the image, and then uses BSSK in order to re-encrypt the firmware image, and thereby provision that re-encrypted image onto the device flash memory, and then issues a reset. So overall, this process is known as firmware binding, which occurs on the first boot on the device itself. Now let's see what happens on the next boot cycle. That remains pretty simpler. So the bootloader, having access to the BSSK, decrypts the firmware blob using the BSSK, loads it into the memory, and continue on the device booting sequence. So this way we achieve benefits of the both key types. First one being that we have a single image to deploy and update, and secondly, we get the added benefits of the per device unique key as well to provide protection against software cloning or such. Now let's discuss what happens when we combine the firmware encryption along with the firmware signature. So let's discuss them in terms of the security concepts first. So firmware encryption in itself, as we have discussed before, that assures confidentiality and integrity, whereas the firmware signature, it assures the integrity, authentication, non-repudiation, and the authorization. So in simpler terms, the firmware signature allows only authorized firmware to execute on the device. So what happens when we combine them both? So encryption and signature in itself, they are very well-known cryptographic constructs. But when the combination is to be used, proper attention is required towards the achievable security properties. So I have listed here 3 possible combinations. First one is encrypt then sign, sign then encrypt, and sign then encrypt then match. So we'll discuss each of them in detail in the upcoming slides. So firstly, the encrypt then sign feature. So in this case, we encrypt the firmware image first, and then put on the signature on top of the encrypted firmware block. So this way, we could achieve the confidentiality, integrity, authentication, authorization, security properties. But there are few shortcomings attached to it. So only the encrypted firmware blob in this case is non-repudiable to the OEM or the service provider. But we would like to have the plain firmware image to be non-repudiable, so that in case there are multiple parties involved in the firmware which are providing the firmware images, we could tie ownership to a particular entity. Second one being the signing of an encrypted blob makes it immutable, so which doesn't allow the re-encryption feature or the firmware binding that we have discussed before. Now coming on to the second approach, sign then encrypt. So in this case, as depicted by the figure on the right, the firmware image signature is placed on top of plain firmware image, and then the encryption is done over it. The achievable security properties are confidentiality, authentication, authorization, and non-repudiation. But there is major backdrop here. as the plain encryption doesn't assure the integrity of the encrypted blob, and which may make it vulnerable to chosen ciphertext attacks. So this approach isn't the recommended one. So let's move to the last one, sign then encrypt then MAC. So in this case, as per the figure here, the firmware image is signed and signature is put on top of it. Then the firmware image is encrypted, and over that a MAC tag is put on top of the encrypted blob. So this way we could achieve all the security properties that are required for firmware, as well as the concerns addressed for the previous approaches as well, like MAC tag assures the integrity of the encrypted blob, as well as it allows firmware re-encryption as well. So this is the approach we have chosen during our implementation in the upstream project that we'll discuss later. Now let's move on to the last challenge about the impact on the firmware updates. So generally, there are two approaches to apply firmware updates. One being to update complete firmware partition, and the second one being to update individual firmware images. So in case of complete partition update, firmware encryption doesn't add any complexity as such. So updater could verify the overall firmware partition signature and update the flash memory. But in the second case of individual firmware images, firmware encryption does add complexity, where updater needs to verify each individual image and hence requires access to the encryption key as well. So the either updater needs to be a secure world entity, or it needs to leverage the secure world decrypt and verify service. So these are all the challenges that I had to discuss. Now let's move on to the implementation part in the upstream. So the first one being the trusted firmware for A-class devices. So it supports an IO encryption layer, which is kind of a pseudo layer that is layered on top of any base IO layers, such as the fifth layer, in order to support corresponding load of encrypted firmware payload. And here the approach used is sign then encrypt then MAC, as I have mentioned before. And the tool is encrypt firmware tool that exists in the trusted firmware directory to encrypt firmwares during the build. And I have listed here the build options that are supported in upstream. So if people are interested to enable this feature on their respective platforms. And also, I have put here the file references if people are interested to look into details into them. Now, let's move on to the second part, being the Opti implementation. So Opti supports loading of encrypted trusted applications from the refile system using a separate image type as mentioned here. So the approach used here is again the sign then encrypt then MAC, and we use this Python script to encrypt TAs during build, which used to generate random nonce for every encryption. And again, these are the TA build options. If people are interested, they could give it a try. Now, lastly, this future scope of work over here. So firstly, I would like to mention that let's champion the open source security framework so that we are able to reduce the redundant maintenance effort that goes into maintaining the increasingly complex custom solutions. And secondly, contributions are very much welcome in order either to improve the firmware framework improvements or adding further platform support. So that's all I had to cover up for in this session. Now I'm open to take any questions if there are any.
Thank you, Sumit.
look at the chat channel.
There was one question on the YouTube that I just added to the Zoom here.
Okay. I think it's not related to this session, probably autonomous driving. Yeah.
Okay. Okay, I guess that's it. We have a Slack channel available if anyone wants to chat with Sumit after this session is over. So I'll drop the link in the chat. And other than that, I think we're good.
Yeah, sure, Christine. Thanks.
Thank you very much.
Hey, Christine, can you hear me?
Hey, Sahaj.
Hey, my promise it doesn't like, show that I'm speaking. I'm not sure what's going on.
Hold on one second. Your volume's really low.
Any better now?
That's a little bit better. Hold on one second. Let me try something. Okay, can you try talking again?
Hello. Any better? Wait, let me see if I have another microphone handy. Then look okay.
I hear some kind of background noise on it. So.
Oh well. Just a second. I will find another microphone that should help.
Okay.
How is it now?
Oh, that's better.
Yeah.
I still hear a little background noise, but I'm not sure if there's anything you can do about that.
There is a cooling fan to keep all the boards cool, so
Oh, okay. No worries.
I'll do a quick camera test.
Okay.
That seems to be working, and that seems to be
Oh.
working.
Yep, I can see you. I can take my slide down if you want to share yours.
Yeah, sure.
Okay. I can see your screen, but I can't see you anymore. I don't know if you did that on purpose or not.
And I'm visible now.
Yep, there you are.
Cool. I guess we do have 2 more minutes, so should I wait or should I start?
Yeah, just wait a couple minutes in case people are come in.
Okay.
Yep, and then whenever you're ready in 2 minutes, you can go ahead and get started.
Sure. All right, looks like it's top of the hour, so I can start. There are people on YouTube telling me not to let the magic smoke out, so I'll try my best not to burn any boats today. But hello, everyone. This is Sahej. I work as an application engineer with the 96 boards team at Linaro. And past year or two have been very exciting for open source GPU drivers, especially in the ARM space. And they have really opened up like a door to a lot of possibilities with dev boards and like a lot of, wow, not sure what happened there, but a lot of old dev boards have sort of come back to life because now their GPUs can be utilized as well in a useful manner. So last Linaro Tech Days, I kind of missed the spirit of Demo Friday. So today's session is more of a demo of different boards running these open source drivers rather than an in-depth, detailed talk about what the drivers actually do. There are people who are far more knowledgeable than me in this regard, and they have talks on XORG Developer Conference from this year, earlier in the year, and that is a really good source if you want to get into the nitty gritty working of Mesa and the Linux display stack in general. I'll go through a bit of that stuff, but um, not a whole lot. I'll be focusing more on the demos because I have some cool tricks to show you guys. So, getting started with that, this is the Linux display and graphics subsystem. Um, Kind of complicated, but it's all pretty easy to grasp when you take a look at this flowchart for a while. So the main thing we're going to focus is on Mesa today, and there are some kernel bits that are there and are required, but mostly the magic happens within Mesa. There's the DRM driver, which is the kernel part that communicates with the user space Mesa driver, and then the kernel itself. The one thing wrong here with this flowchart, I won't actually say wrong, but could have been added, is that usually there are two DRM drivers working together, because take an example for the RK3399 where the actual display subsystem is provided by Rockchip. So you have the Rockchip DRM driver for the display subsystem, and the GPU is provided by ARM Mali IP, and that's provided by the Panfrost driver in our open source situation here. And similarly, with a lot more, like Allwinner has their own display DRM, and then some of them like IMX, AM Logic, STM, all use the DW designed by display subsystem IP, but they still have their own like driver. So you'll have Mason DW driver, STM has its own DRN driver, and so on and so forth. So apart from that, yes, Mesa is sort of the thing that magically translates EGL and OpenGL and Vulkan and OpenCL calls on to and run that on your GPUs. This is the sort of messy clockwork magic of Mesa. Now, this is not the entire Mesa project concise in a few in a small flowchart. No, this is just the compiler stack, and basically NIR is where all the magic happens. It's been standardized a lot more. NIR is this magical layer which converts your all the shader stuff uh, into the sort of the intermediate level, and then it spits out whatever driver you're using. So in term of Panfrost, Panfrost driver relies on an IR, and then um, so does Freedrino, so does Zinc. TGSI is sort of the depreciated version. There are some old drivers, some really old NVIDIA stuff. Etneviv still uses TGSI. Um, and then the LLVM pipe, which is the software renderer, uses TGSI. Um, LLVM pipe is another really great stuff that I like because it uses the Clang backend. It has the ability to be highly parallelized. So if you ever run anything on LLVM pipe versus VertIO, you can see like while running it while running Edgetop, you can see the CPU utilization differ quite a lot with LLVM pipe, utilizing as much cores as possible. The other thing that LLVM pipe, or I should say LLVM IR, provides is OpenCL support using again the Clang backend. So that is used by Mesa's Project Clover, and all the LLVM pipe um, and the Radeon drivers, so RADV and Radeon SI, both use the LLVM IR as the backend. And so the Radeon graphic cards, and if you're using LLVM pipe, you can actually run OpenCL on Mesa. As far as I know, there's some work going on to get uh, OpenCL over SPUR-V running, and at that point, you will not need LVMIR to get the OpenCL stuff running. But yeah, so that's sort of the overview. Again, more details is like on XORG DevConf, and I'd recommend everyone go there. So off to the good parts, which are the actual demos. Um, First one is at Naviv. Now 96 boards has a few boards. We have the IMX8 based AI/ML boards, and we have the Thor 96, again IMX8 based, but both of them have, I think, not don't have the HDMI stuff upstreamed yet. Also, STM32MP1 is a much recent sock, and after a long time, I've seen someone other than IMX utilize the Vivante GPU drivers. So this one uses the Vivante GC400, which is like their super low cost um, solution, which is like they have um, like less than 1 millimeter square silicon area and stuff like that. So it supports very basic OpenGL calls, and extremely cheap to implement, and it's a low power solution. So let's actually switch. I'll need to stop share and switch over to my webcam. I'm not sure if I'm being pinned, but I think is my webcam being pinned or not? I can't see. Um,
I can still see your black screen with the code on it.
right. So I guess everyone can see that then. Which is right. So I don't have an XORG based or like a GUI based demo here. Uh, I just didn't have time. This is a basic build root build, but you can see it's a um, dual core Cortex A7 solution. This is the STM32MP1, as I mentioned, with the GC400. Running the latest mainline stuff, 5.8.7. I just built it recently, and I can run KMS Cube on it. Runs on the open source driver just fine. And again, if I back out in a second, it clearly shows OpenGLES2.x on Etneviv and Vivante GC400. But if you see at the frame rates, they're not very exciting. But like that's what the performance of this GPU. It's basically made for basic. Um, I'm guessing Qt based GL stuff that runs on embedded processor. So like even the basic KMS cube only runs at 60 FPS, and I'm pretty sure that's not a refresh rate limitation here, because I've had it also show 70 FPS on certain other when it's like properly cooled and stuff. So it's not uh, a limitation of the monitor refresh rate. But yeah, that's for the Etneviv stuff. That's the only one I have at hand right now. So we'll move on to our next demo. This was a short one. Next up, we have Panfrost. Before I go further, I mean, congratulations, Panfrost people. Like basically, ARM giving you all the support they have, and this is actually amazing news that ARM is now backing the project. In any way, they like. I hope that this support leads to ARM actually releasing Panfrost-based drivers for their upcoming GPUs out of the box rather than the binary blobs they have. It's a pipe dream, but anything's possible at this point. But just ARM coming out and openly supporting the project is amazing news. So yeah, that like really shows the power of open source. But yeah, Panfrost provides the open source driver, again reverse engineered initially. I'm not sure how they'll go forward now that ARM is being involved, and provides support for Midgard and Bifrost GPUs. Today, I'll be showing it on the Rock 960, uh, running the RK3399 with the Mali T860 MP4 GPU, so kind of a mid-range deal with OpenGL ES 1.12 and 3, and we'll be demonstrating the GL3 as well. I so again with Panfrost, they have done work on Bifrost or the G series GPUs as well. Again, we have a couple more boards, and this is where the interesting DRM bit comes in. Like we have Heike 960 and Heike 970 both running Bifrost GPUs, which would have been a great candidate. But now, remember the second DRM bit that I talked about, which is the display engine on the SOC. So that's not upstreamed for those boards. So that means even if we have the Bifrost GPU running, it runs in an off-screen mode because like the SOC can't display anything because that DRM bit is not enabled in an upstream kernel as I recall. The Heike has DRM enabled for High Silicon has DRM enabled for high 6620, which is in the original Heike, uh, but the IP changed when they shifted to the new platform. So 960 and 970 have the same display engine DRM IP from High Silicon, and that's not upstreamed. So I have the Rock 960, and let's get to the demo of running cool stuff with it. The other thing is that this board is kind of touchy when it comes to switching HDMI. So I will have to plug and replug and then power on the board. This board is running uh, Fedora 33, and since the U-boot is pretty much well upstreamed, I'll stop screen sharing so you can see U-boot boot. Yeah, like the U-boot graphics work as well, so display output works as well and everything. So this is mostly EBBR compliant from what I recall, and I have been off on and off working with Peter Robinson to test this board and make sure that it's well supported in Fedora. So hopefully, yeah. So it's running up all everything upstream, like U-boots upstream, and then proper distro. So just waiting for it to boot takes a few seconds, and I was afraid this was going to happen. I'm not sure why the HDMI is so finicky on this board, but yeah, GNOME should show up any second now. There's pointer. And there we have it. Login. Right. So as you can see, wait for it. I spoke too soon. Yes, running stuff from SD card is not the fastest way to do things. when your bootloader's on the eMMC, what other choice do you have? So there we go. Boots into GNOME just fine, and GNOME is working fine as well. But that's not the stuff we are looking for. What we really want is some GL Mark II runs. Now, of course, I won't be going through the entire like GL Mark II suite. It's just going to take a lot of time. But just to prove a point here, it's running Panfrost on the Mali GPU. Again, GL Mark II is just 2.1, so you won't see any 3.0 stuff on this demo. But if I run Super TuxCart, um, oops, that actually runs OpenGL3. Actually requires OpenGL3, not only runs OpenGL3, and that is an actual demonstration of the GPU running in OpenGL3 mode. So there we go, and I can go into a quick race. Wait for a few seconds again. We are running on an SD card. While this loads, EBBA should have like SPI flash mandatory. Um, this is, whoops, that's not supposed to happen. All right, I'm not sure why it crashed. It usually runs fine. Um, but what's a talk without stuff crashing? But I've run this, so I can actually run another demo that might work better. This one's called Mindtest. It's a Minecraft clone, but it's like a really good clone. Um, it basically supports up to open, like I've run it on OpenGL2 as well. We'll be happy with whatever it gets. So yeah, it's a voxel based game, so it stresses the CPU a bit. But what we are looking for, that there are no rendering artifacts, and it's working just fine. The smoothness really depends on what environment you are in within the game, and it can vary from like place to place. If it has to render less blocks, then like FPS will increase quite a bit. But if you're in a space where there's large open things to render, then it will have issues. But anyway, I think this is good enough demo on my end for Panfrost. Performs well enough. Um, and I've never run this GPU using the closed source driver, so I'm not really sure how close it is to like the actual GPU's performance. But I'm liking what I'm seeing. So like, yeah, I'm getting close to 30 if the conditions is right, which is good enough for a low to mid range GPU. So good on Panfrost folks, and I'll be keeping my eye on the Bifrost development that happens, uh, because it's going to be nice to see or actually have another demo, hopefully in person, um, when possible next year. Right, back to the slides. So the next bit is Freedreno. This is available on a bunch of our boards, starting from DragonBoard 410C, which is the Snapdragon 410C based board, and then the one that I'll be demoing today is the RB3. There's also the DB 820 in between, or DragonBoard 820. The RB3 is based on the Snapdragon 845, which is last year's or last generation's top end smartphone SoC. And then we now have the RB5, which I don't have in person due to shipping issues. Right now, the world's not entirely sane, so shipping is weird as well. Um, yeah, so RB3, I'll be demonstrating. It's a really really nice sock. It's a really high end sock. So yeah, demo is going to be cool. Uh, again, yeah. So FreeRhino provides the MSM DRM drivers, the actual FreeRhino or the Arduino drivers, and the XF86 stuff to run Xorg on. But again, we'll be using the Qualcomm Landing Team's Debian distro to run it, which runs very close to mainline, with some to be merged patches already applied. So we are running very close mainline stuff on this, and this does up to OpenGL ES 3.2. I'm not entirely sure what the FreeRhino drivers goes up to. I think it's pretty close. So again, I'll switch back, and I will quickly switch out to the RB3. Oops. Oh, which can I do? And there we go. So as you can see, the Snapdragon 845, and we are running kernel 5.7, very close. Now this has Mesa master build for a very specific reason, which we'll see in our next demo. But just for a quick look, um, I'll run Super TuxCard on this. Uh, and this is running on. Oh, did I not install Super TuxCard? Oops, my bad. We'll run mine test. And since this is running actually pretty decent GPU, one of the more higher end ones, um, it gets much more FPS. So you can see we have around 45 to 50 FPS, and looks really smooth. Now I do want you all to sort of notice the sort of a glitch. Now I have opened up an issue with the Freedraino folks, and this is being looked into. But I need you to look into this transparency issue a bit closer for some other reason, which my next demo will clear out. Um, so we'll just exit from here. Uh, I'll give you guys a quick run of GL Mark II so that let's see. You guys can see what the actual performance is. So we are getting around 1700 FPS on the first test, uh, which should be a ref indication to what this GPU is actually capable of. Now to the much more cooler part, something called turnip and something called zinc. Now Turnip was a project that just got like announced last year. So I was at the Bangkok Linaro Connect, and I've heard about it that there. And it's an open source Vulkan driver for our Adreno hardware, so for the Qualcomm GPUs. And when it was announced, the first thing the description was it renders a very specific Vulkan triangle. So it was in no way compliant. It didn't run general demos. But now, like just 1 year after, it's been merged into Mesa, also like just directly a part of Freedraino driver now, much better code base, and runs a lot of examples really well. Like they say that it's not a fully compliant one, but like I've put in it through its paces. Of course, not done the compliance test, but in terms of demos that are available for Linux and that can be compiled for ARMS, it's run them just fine. And then Zinc is an OpenGL implementation on top of Vulkan, so we'll look at that as well really quick. Um, and I will stop the screen share. And so on here, I can run VKMark, and that runs just fine. So I can just go through all of the demos in VKMark, and it runs fine. Again, it shows the warning that it's not conformant to Vulkan implementation, but it's still running fine. So it was getting around 6,771 FPS on the first demo. which is kind of comparable to what the OpenGL stuff does. Um, the other demos we have is from Shasha Williams' library of Vulkan demos, which have been there for a while and sort of one of the best sources of testing out Vulkan in a fun way. But I'll just run one of the demos because again, it's going to take a lot of time if I run every one of them. Um, but again, I have tested every one of them and it runs fine. So this is compute cloth. Just looks kind of looks cool when it's running, and it's it's computing the actual fabric simulation, how it should fold and everything around a sphere, and yeah, that just runs fine. 141 FPS, which is comparable to a lot of benchmarks I've seen with this demo, and um, yeah, VK is running fine. But like the crazy part is like it's the turnip is good enough to run zinc, and zinc is again, as I said, an OpenGL implementation over over Vulkan, and that is hardware agnostic. So if you have Vulkan driver enabled, you can basically get OpenGL as well, which sort of shortens the time for a driver development. You just have to do the Vulkan stuff, and you get the OpenGL stuff through Zinc, and it works fine. Of course, there is a performance penalty now, but there's no reason it couldn't improve in the future. It's a very very young project, and for the most part, it's running fine. Now, if you remember the mind test glitches that I showed you, now because this is a fresh implementation of OpenGL, again over Vulkan, those glitches aren't apparent anymore because they go away. It's like, so see, all the transparency is back. Of course, we have taken a massive hit in terms of FPS, but again, this is like the same demo as before, but again running on Zinc. So if you only spend time developing the Vulkan driver really well, Zinc helps you get to OpenGL very, very quickly. You just enable that. So again, this is even more beta or alpha level stuff than Turnip because you have to specifically enable it by overriding the default Mesa loader, and yeah. So this was sort of the array of demos I had for the short time. I'm not sure if I've overrun the time, but I think,
Just a couple minutes.
yeah, all right. I think I can take questions, and also I'd like to thank all the developers of these various projects who have helped me along the way, and I've been asking them questions on IRC for the last year or so, um, and especially Daniel Stones because we've just had a chat on over email about how all the internal Mesa NIR stuff works. So thank you for that. Um, yeah, I hope like these developments go forward, because open source GPU drivers just makes life easier to bring ARM to desktop. And any questions there may be.
Thank you, Sahaj. I just put the Slack link to your session into the chat. So if anyone has any questions, they can head over there and chat over there if that's okay, because we have another session starting.
Yep.
Thank you, Sahaj.
Thank you, everyone.
Hi, Tilla.
So, hi, Christine. So we are online.
Yep, we're good to go. So you can share your screen and then you can go ahead and get started because we're right on time now.
Okay, I'm just looking for how to, yeah. So now I have the function to say share my screen. That's great.
Okay, I can see your screen now. I can't see your video though if you're planning to share your video.
Okay. So welcome everyone. My name is Attila Ambrus. I'm from Linaro Electronics, working here for more than 5 years, responsible for SOMS board solutions, also covering the EMEA 96 boards activities inside Aero. Today, I will have a very short session, so I will be fast. I would like to hear your comments on how to improve the awareness of the 96 boards, what can be done better, and what are the main problems which actually blocks the 96 boards to have bigger awareness on the developer community. So let's see the 96 boards in numbers. If you check the 96boards.org, you can see that we have 18 boards from the consumer specific edition. We have 5 from the enterprise edition, 9 IoT boards, 3 SOM edition boards, and 22 mezzanine cards. If we add all these together, we will have around 60 boards. In comparison, on the project number of posted projects on the 96 boards, it's only 84. So if you calculate this, it's like 1.1, 1.2 projects per boards that was created for the 96 boards. So actually, this means to be a brainstorming session. So I'm really encouraging you to give your inputs. How can we be more visible for the developers, for the community? How can be more competitive against the alternative development kits like Raspberry Pi Arduino platforms or the dedicated SoC manufacturer development kits? So I really would like to hear your thoughts on what are the issues we have with the 96 boards community and what are the things that we should done to make it a better way. Actually, I'm listed, for example, some problems what I'm assuming we have. So the still low awareness in the development world. I'm organizing a lot of trainings based on 96 boards platforms what we created. Actually, I'm starting always with whoever heard about the 96 boards community, and the result is really low, like 1 in 20 people. Pricing comparing the competition like Raspberry Pi is can be one issue, and competing against SoC manufactured dev kits can be another issue, and lack of real 96 boards cross compatibility, because we have the standards, we have the specification that provides the compatibility on the hardware level. But actually, when you just want to plug and play any mezzanine into any baseboard, you will be facing so much trouble. So actually, I'm really interested in your thoughts, in your inputs, what can be done better. I think we can see the Slack chat, or you can post anywhere on the Zoom if it's possible. I don't know. So I'm checking the Slack chat. If you have any inputs, please feel free.
Also, if anyone wants to raise their hand, I can unmute them.
That would be the best.
Yeah.
I'm sorry, I'm already in the participants list, so I can unmute myself. But I have a couple of comments on the issues, especially like being so close to the team. So the I don't see the price factor going down unless someone takes a hit on the actual sales. So till SOC vendors treat it treat the boards as a product, it's always going to be expensive. But once you treat it as an investment, and actually take a price hit or like even a loss on sales of each board, in order to gain more traction and uh, more customers for your SOC itself. Till then, prices can't be lowered down. We saw this with the Chameleon 96 recently. It just went down in price by a lot. It was being sold for more than $100 and it went down to 30, and it sold within minutes because just it was cheap enough that people wanted to get their hands on. And like now, after that board has been released, so many years after that, people are actually working actively. Like I'm on one of the Telegram communities. I'm on our Discord, on the ARM Dev Cave, or on the ARM Discord channel, and everywhere. Like I've been talking to people who are working on build root builds, working on getting distros using the upstream Linux kernel working. But what happened again back in the day was that Chameleon 96, and I'm talking about the Chameleon 96 as an example, and don't want to name shame anyone, but because that board just suddenly went down in price and we saw the immediate effects of that. So taking price as the factor, like vendors needs to understand that, um, that taking a loss is why you make dev boards, not to make profits. Same what happened with the Dragon board, um, 410C, like it was almost sold at a cost, from what I understand, at 75. And then the Ultra 96 again, like that FPGA is expensive, and $200 is a very, very, very low price for what that FPGA can do and what it's actually worth. So, um, yeah, that's sort of
So
my
Saj,
take.
you are seeing a big potential in investing in development kits
Yeah,
just to lower the price below the market price, and with this we can reach wider audience with our boards. Yeah, that's a good point. Yeah, actually we are, at least Arrow, I can speak in the name of Arrow. We are trying to reach at many customers, many people with actually free on hand boards. So we are running multiple campaigns. We are giving away boards on events. So we usually cannot go lower on that. You need to understand that we cannot just give away boards without the project potential behind it. So any other points from anyone else? Don't be shy, we are certainly in the line, and we are really interested in anyone's opinion. So I don't see any inputs on the chat.
actually, I'm being pinged on Discord by David. He cannot unmute or join Slack. So, his question is, what about booting, and how would standardized booting help? Um, and I guess what he's trying to say is um, up, like upstream kernel support and upstream bootloader support, so that you're not always tied down to vendor BSP. And the when sometimes like the drivers they provide are not what you really need. So again, I'm kind of going back to my GPU session that I just had. A lot of the times I've seen vendor drivers being locked down to Weston or API, the Weston renderer, and that's all it can do. And other weird quirks like that, where you'd want some functionality with that's introduced in Linux kernel 5.8 or 7, but like the vendor BSP is locked down and not upstreamed, and you're getting like 3.12 or 4.2, stuff like that. So this and again, taking one of the examples of the boards we have, the Avenger 96, the SOM provider DH Core invested, and they actually sponsored upstreaming of this board, and it has great software support now. So I guess the question is that how like better upstreamed from the get-go, will that help?
Yeah, that's gonna be a good point. Also, we are seeing that from our SOC partners, this is a demand more and more from their side as well. And actually, they are going to that direction to have upstream and mainstream Linux support on their BSP. So what we can see that they really recognize that this is a must for their processor solutions and also for the dev kits. So actually, I think in the future it will be more like standardized, and this will be driven from the SoC side as well, not just from the 96 board partners.
Yeah, I think also we might want to start advertising that, actually using that, because like again for the Avenger 96 and a couple more boards that's been upstream, there's no actual distro that uses that upstream kernel. So maybe talking with guys at Fedora, or even having like a Yocto meta layer that uses the upstream kernel rather than the PSP one, makes life a bit more easier.
Yes, I agree. So we have a chat. Have you guys followed what Pinebook Pro, Pinebook, Pinephone are going or are doing? Sorry. It's a very active noisy community. 96 boards could do well in trying to convince and one of the OEMs to open up and order products. So actually, I'm not really aware of this Pinephone and Pinebook. I will check. There is a post from Daniel Thompson. How much of the 96 boards ecosystem is professional development being paid to make products? They will never contribute projects for the community. They are also happy to pay enough to allow the boards to be sold profitably. Yeah, so actually we are in partnership with a lot of companies, and there are different business model with them. Actually, we are trying to force them to create a profitable product, which then it's they initiative as well to drive it and support it well, to finally, or in the final, it will sell sell itself, and we don't need to really force it and to make a really big market around it to be sold. And this is the main target for us now. What about trainings around the boards? I don't know. No one reached this point. If we can build up some general 96 boards trainings or webinars, which actually the people can go through, have a certificate at the end or something. What do you think, Saj?
Oh, I was reading another comment. Someone posted it on my older Slack chat for
I'm
my
sorry.
session, which is actually for you. So they're posting in your Slack now. Can you repeat your question?
Yes, so actually I was thinking about organizing some standard 96 boards webinars or seminars around the 96 boards ecosystem, like multi-week webinars where the people at the end will get a certificate or something that they can use. Do you think that it would open up a huge channel for the audience?
Yeah, I think so, but like we really need to invite more sock retailers and board like board builders, makers. Um, so people you've already worked with, and people that already have 96 boards products that we feel might not reach our expectations in terms of compliance and all of that stuff. So like a few webinars to just go through what the actual compliance means, and and then a few more about upstreaming and stuff like that. That should do some good. Maybe educate people a bit more to rethink the ways they've been operating, because like it's a known fact, like providing a BSP within a virtual machine image, uh, that's not uncommon. Like that's a very common practice in the embedded space, as bad as it may seem, but people do it. So I guess there's a fair bit of education that's required, um, to get people to understand what's actually required to sell SOCs and sell dev boards.
Hmm.
Um,
Yeah, actually, it would be great to give the people the basic knowledge. So using that, they could really boom the project sites of the 96 board, because I believe that the 84 projects which already exist on the site is a really low number in comparison of the number of boards that was released in the last couple of years. Checking again the chat.
there's one on Slack as well.
For 96 board, I've always wondered why there is not more of an emphasis put on the boards being open source hardware, schematic and layout CAD files published as open source. This helped grow the BeagleBone community, and I think it is a way different from the Raspberry Pi, where there is no interest in open source hardware documentation. Isn't it the best interest of the Silicon vendors and Linaro members for 96 boards to go with reference designs for the SoCs? So it's actually a good point. For some of the boards, I can speak in the name of Arrow Electronics. We have the design files and everything, but actually it's so complex. So I believe it's not easy to use it for your own product, to customize your own product. Also, we are working with some and board manufacturers who of course don't want to give out the work they put into designing these boards and SOMs. So in that case, of course, they want to sell their products as well. So it's not possible to make it open source. So this is the two options. But I believe that as the SOCs and DRAM routes and everything is getting more and more complex, the customers are not really can make benefit from having the design files of such a board. This is my feeling, and I believe the software support is really getting a bigger and bigger help for those customers who want to actually work with these new processors.
And yeah, just to like add to that, as per our compliance, we do require all of the uh, board manufacturers to provide schematics, and we try to enforce that as much as possible. So schematics and yeah, layout CAD in terms of if you just want to like make cases and stuff, that's usually generic between a lot of the boards. Sometimes the stock placement is a bit different depending on if it's on the top or the bottom side of the board. Um, but like we do have a fair amount of boards that provide both CAD layouts and schematics.
Yeah, that's true. And also, usually when the customer is coming to Aero Electronics and want to actually do something similar to what he has in his hand, an 96 board, we are really happy to support it on any level, from schematics to designing and whatever, mainly on the BOM level. So it's not a hidden stuff, but actually we don't really want to have the customers go directly. Our business model is like a selling component, so that's why we want to keep the customers what we reach out with the 96 boards. So any last comments, because we have 3 minutes left? So a couple of things coming in chat. I'm not sure I can answer or reach each of them. So we are still discussing the layout and schematic and PCB CAD files on the chat. So there are some people who are agreeing to source it out, and some people are not agreeing to share it with customers because they are understanding what is the business model. I think we will continue on the Slack channel. I would like to thank you, all of them who participated and give the inputs, especially for Sahaj. So thank you very much for Linaro Connect to have the possibility to be here and getting the input from the community. And have a nice day to everyone.
Thank you, Attila.
Hi, Kristen. Can you hear me?
Hey, Shibu, I can hear you.
Okay. Yeah, I'm ready with my slides.
Okay, just move my slide.
Can see my slides now.
Yes, I can see it.
Yeah, just let me know when we can start.
Okay, I'm just gonna wait one more minute and then I'll let you know. Okay, you can go ahead and get started.
Okay. Hello, everyone. Today's presentation is on Trusted Firmware M, some of the recent work we have been doing on profiles, and we are going to finish off the presentation on a demo based on Profile Small. Myself, Shibu Kriakos, I'm part of ARM's open source software group and product manager of Trusted Firmware M. Joining me in this presentation is David Wang, the TFM tech lead. We all have been hearing for a few years now there are going to be 1 trillion connected devices by 2035. And all these connected devices are getting closer and closer to our daily lives, whether it's in the form of baby monitors, health wearables, or cities trying to get smarter. And the whole coronavirus situation seems to have just accelerated the IoT deployments, whether it's in terms of remote health monitoring, drones that are used to deliver medicines and to clean our streets, or even to track the movement of important assets and people itself. However, one of the common themes that we hear with connected devices is, are they all going to be secure? Just citing here one of the IoT Business Index surveys that concluded earlier this year, which cited 45% of the respondents, especially in the enterprise space, still thought security concerns are still hampering the adoption of IoT at scale. So that just reiterates the fact that it's important to solve security in a scalable manner to achieve the dream of 1 trillion connected devices in a few years' time. This is where the platform security architecture program, which offers a complete offering to build your secure connected devices, becomes very crucial. And as part of the program is the open source reference implementation Trusted Firmware M, which allows devices to adopt the project and get themselves certified either as a silicon or as an end device. So let's look at Trusted Firmware at a very high level. Trusted Firmware M provides a secure processing environment for Cortex-M devices, especially V8M trust zone enabled devices. It provides that isolation between the secure and non-secure world by leveraging the trust zone that is available on the hardware. It provides a secure boot that authenticates all the runtime images on the platform, and it also supports a set of runtime secure services, whether it's storage to confidentially store all the critical assets on your platform, or to store things like keys and certificate away from the non-secure applications and operating system. Crypto service that makes itself available through these PSA crypto APIs for doing all sorts of crypto operations, whether it's signing, signature validation, or to do TLS connection to other remote entities, and an attestation service that can be used to prove the identity of the device to a relying party like a cloud service. As TFM has evolved, we can see that there are a lot of devices now enabled with TFM as its root of trust. I'm showing a few examples here, whether it's the NXP LPC55 platform, ST's STM32L5, or the Cypress PSOC64. All these devices, either through upstream TFM support or through SDK distributions, use TFM as the root of trust and have got the relevant PSA security certification as well. At the same time, TFM is now starting to get integrated on all the popular open source RTOSes, like EmbedOS, FreeRTOS at the kernel level and at the Amazon FreeRTOS level, and with Sapphire integrating TFM for many silicon platforms. In addition to all the work we've been doing around these platforms, enablement, and RTOSes, TFM profiles is an area that we have been looking at very carefully for the last few months now. If you take the overall IoT device landscape, which is where Cortex-M and therefore TFM is targeted at, you can see there's a huge variation in the type of devices that you call IoT connected devices. It can vary from your home smart bulb or a thermometer, or a slightly complex system like an asset tracker or a smart meter, or even more complex systems like a drone or a small robot or a gateway. Although all these devices do use a Cortex-M CPU, all these devices have a very huge difference in the device capabilities. So a low-end Cortex-M CPU might have limited performance. It might have only a few KB of RAM and flash at its disposal, whereas a high-end Cortex-M device might have a high-end Cortex-M CPU, of course, with higher performance and with a few MB of flash at its disposal. So it's quite apparent that it's impossible to give a single configuration ready-made TFM root of trust firmware that satisfies the need of all these use cases, its security, and that can fit into these different device profiles. So this is where we have tried to categorize the overall IoT device landscape into 3 categories and try to define TFM profiles into these 3 categories, namely profile small, medium, and large. What this means is we are providing, as part of the profiles, a predefined list of TFM features that aligns with the typical use cases and understands the hardware constraints in each of these categories. And these TFM profiles can be used as reference profiles for application developers when they're targeting each and every use case, and they can add or remove features from these predefined list of features in each profile to match their exact security requirement for their particular use case. Now, let's briefly look at the various profiles that we've built over the last few months. Starting with profile small. As the name suggests, it is the lowest memory footprint TFM profile that we have created. It is aimed at ultra-constrained devices that runs very simple IoT applications. These are the sort of devices that wouldn't normally connect directly to a cloud service. It would normally connect to a local hub or a gateway, and the gateway would then connect to the cloud. We have a demo at the end, as I said, which shows profile small actually in use. And with profile small, it's still not a bundle of security requirement. These set of security features gives you enough functionality to meet the PSA Level 1 security certification requirements. If you look at what Profile Small offers under the hood and compare that with the TFM diagram I was showing a few slides back, what it provides is a very simple TFM lightweight framework. It only provides one level of isolation, so it only separates the non-secure and the secure world. It doesn't support the higher levels of isolation that PSA defines. It allows buffer sharing between the normal world and the secure world. It only supports one secure context, meaning that an application can have only a single call. A second call to the secure world will have to wait till the other secure service is serviced completely. There is a secure boot, but with very basic functionality. It do have anti-rollback protection, but in terms of firmware or software update, it can only update the entire platform image in one shot rather than updating the secure and non-secure world separately. In terms of runtime services, it supports the internal trusted storage. So it supports securely storing your keys and certificates on an on-chip storage, which means the assets are not encrypted because the storage is part of the SOC itself. It doesn't offer any rollback protection, again, because it's backed by an on-chip storage. When it comes to the crypto service, it just supports symmetric ciphers, which is the typical cryptographic ciphers that you would need in such simple applications. So you would normally have something like an AES suite. You'll have SHA-256, HMAC, those sort of ciphers. You wouldn't have something like ECDSA or RSA supported as part of this cipher suite, but you can still do a pre-shared key TLS connection if you want to securely connect to your local gateways. There's the attestation service. Again, it is based on symmetric key algorithm. Again, it supports attestation, which can be used to prove your identity, but again, it is limited in terms of just supporting symmetric key-based attestation service. You'll see more about it in the demo that David is going to show in a few minutes. If you now move on to Profile Medium, this is again aiming at constrained devices, but slightly richer devices compared to what Profile Small is targeted at. These sort of devices would typically try and connect to the cloud services directly rather than going via a gateway. And this means that there should be more security inbuilt in these devices compared to a device that is aiming at Profile Small. Still, it provides enough functionality to meet the PSA Level 2 certification requirements. And again, just like Profile Small, if you look at the features that is available under the hood, it supports secure boot, but again, a bit more feature rich compared to what is supported in Profile Small. So secure boot here still supports anti-rollback protection, but it also allows the images of the secure and the non-secure side to be updated separately, which means these devices, if they have different vendors providing the secure world and non-secure world firmware, these can be updated separately without having a dependency on each other. In terms of the framework, it is not supporting the library model. Instead, it supports the PSA firmware framework IPC model, which offers the level 1 and level 2 isolation. So it's the IPC framework that is used for interpartition communication and for communication between the non-secure and the secure side. In terms of services, it supports the internal trusted storage for storing keys. It can also support the protected storage where you can encrypt the assets and store things in an external flash. The crypto service, it's a bit more rich. So here it supports both symmetric and asymmetric cryptography. So you have the possibility to having ECDSA, you can do signature verification, you can have AEDs type of encryption of your assets. And of course, you can use the crypto service to establish a full TLS connection to the cloud service. When it comes to the attestation service, it again allows you to prove your identity to a relying party, but here it uses the asymmetric cryptography or a public-private key pair to sign the attestation token. And finally, looking at the Profile large configuration. I would say it's very much under design. So profile small and medium is now supported in TFM upstream. You can have a look at the detailed design if you go to the project. Profile large is aimed at less constrained devices. So you might have a few MB of flash and a higher end Cortex-M CPU at your disposal for achieving a more complex use case. There can be multiple vendors providing firmware to these type of devices, and it might have to cater to sort of higher attack potential, like attacks at a physical level as well. And if we quickly compare it with profile medium, this would be much more feature rich. It would have still the IPC model, but it would support the level 3 isolation, which means you can have separation between the different application root of trust services. So you can have your own custom secure services as shown as green blocks here, but without having to trust each other. It would still have the storage functionality, but it would support both protected and internal trusted storage. The crypto service with all possible ciphers and the attestation service as well. But this is under design, and you'll see more details around the design in the coming weeks in the mailing list. With that, I would like to hand over to David to talk about the profile small demo that we have put together.
Thank you, Shibu. Can you hear me?
Yes, and you can start sharing. No, stop sharing.
Can you see the slides?
Yes.
Okay. Yeah.
Yes.
Thank you. Yeah, I'm David Wang from China. So I mainly focus on the TFM ecosystem enablement. So in this section, I introduce the profile small demo. So this is a use case of the demo. So basically, as Shibu introduced, the profile small just supports the symmetric cryptography. So we need to connect to the gateway instead of the cloud directly. So the gateway supports the TLS PSK, which is a symmetric based TLS connection to secure the communication between the device and the gateway. So in this example, we have 3 devices which are all ARM-v8M devices running TFM profile small, connect to the gateway. Gateway is a Raspberry Pi 3B. So the gateway can connect to the AWS cloud based on the TLS 1.2. This is asymmetric based. Okay, so the gateway will, when the TLS PSK connection is established, the gateway will do the initial attestation check for the devices to make sure the device is in the correct secure state or life cycle or had the correct secure components. Okay, so this slide is to show the software components of this demo. So in device side, we run the TFM profile small in the SPE, and we mainly focus on the crypto and ITS service used by this demo. So, and in the non-secure side, we run the FreeRTOS and an application to handle the TLS PSK client request, which will establish a TLS connection and forward the initial attestation request result and the following application data. The gateway on the gateway side is based on the Linux, and yeah, it's a Raspberry Pi, you know, and it connects to the AWS cloud through the AWS IoT device application. So the TLS PSK server application running on the gateway is to establish the TLS PSK connection and send the initial attestation request and verify the initial attestation token, and also forward the application data to the AWS cloud through the AWS IoT device application. Okay, so this is the workflow of this demo. So The first stage is to establish a TLS PSK connection. So the key point here is we leverage the crypto and secure storage service. So the PSK, the pre-shared key, is provisioned in factory stage in the secure storage service, and in the handshake stage, the non-secure side application can use the handle of the key, but it cannot export the key to generate the session key to secure the TLS connection. And when the connection is established, the gateway will verify the device by sending the initial attestation request, and the device will ask the secure side to sign the initial attesting token and reply to the gateway. So the gateway, if a gateway is fine with the secure status life cycle of the device, then it will go to the next stage. In next stage, we create another secure partition running the sensor, running a sensor application. The sensor application is to collect the temperature and humidity data in the secure world and send it to the gateway. And the gateway will forward this data to the cloud. Okay, this is a video for the demo, which may help you better understand. Can you see the demo, the video?
Yes.
Okay, cool. Yeah, basically this what I said, the three devices connect to the Raspberry Pi connect to the AWS cloud. So, and here's an example of how mask B connect to the Raspberry Pi, the gateway. So yeah, we have TFM Pi Small running in the secure side, and FreeRTOS and application running in the non-secure side. In the gateway, we run the Linux and some applications. So in the handshake stage, the device send a client hello. This is a standard TLS PSK process. So server reply server hello, and at this stage, we agree to use TLS PSK, and the crypto set with this supported. And the difference from the standard TLS PSK is that we generate the session key in the secure side. So which is that we use the PSK handle stored in the PSK stored in ITS in internal trusted storage, and non-secure side can use the handle to generate the session key. So in that case, it cannot touch the pre-shared key. So, and when the handshake finished, the application running on the device can use the session key stored in the secure side to encrypt and decrypt the message for the application data. So when the connection established, the gateway will send an initial testing challenge, and the device will sign the report, the initial testing token, and send back to the gateway. So this is the video of the demo. So yeah, this is a UART message. This is on the gateway side. We started the gateway, and the one board connected through the TLS PSK, and this is another board connected, and they will all verify the initial testing token. So the board sends the temperature and the humidity data. So this is the in AWS IoT Cloud. So yeah, the cloud can get the data. Yeah, this is a video for this demo. Okay. Okay, so basically this is all for the demo. So do you have any questions?
There's two questions in the YouTube. I'll put them in the chat here.
Okay. Shibu, I think this question is to you. Hi, Shibu.
Can you hear me?
Yeah.
Okay, sorry, my mic was muted. Yeah, hi Eric. Yeah, multiple vendors for large profile refers to level 3 isolation, isn't it? Not entirely. So there can be a scenario where there's no level 3 isolation, but the secure and non-secure images are coming from multiple vendors. So a silicon vendor might be fully owning the secure side, and the non-secure side is completely owned by the OEM. So there also it can be a multi-vendor scenario. So there's no level 3 isolation. The silicon vendor manages the secure side, maybe just running in level 1 or level 2 isolation. And the application or the OEM always is in charge of the non-secure side. So our thinking is for low-end profile small devices, it doesn't, the systems are or use cases are going to be very simple, that one party is going to be owning the entire thing. So the secure boot just need to care about updating the image completely. So MC boot doesn't have to be enabled with multiple image feature. But when you come to profile medium, our thought process is the use cases might have multiple vendors owning secure and non-secure sites. So in profile medium and large, we would enable multiple image in MC boot. Whereas with a small, we would disable that just to save some code space. And as I said, it's always configurable. If someone wants profile small with multiple image update, they just need to enable a flag in MC boot. The second question on flashless MCU, I think we have had the discussions in the mailing list. It's of course possible, but to be honest, I think there is more work to be done in the current TFM over and above all the profile work to support flashless MCUs, because one of the PSA certification requirement is to have sort of rollback protected internal trusted storage. So if you don't have a on-chip storage, then you'll have to emulate that functionality in an external flash with some sort of rollback protection, maybe using some sort of OTP fuses or some sort of NV counters internally in the system, which is not supported today. So maybe we can, of course, add it in the roadmap, and maybe as a community, we can solve such a use case. I know there are certain devices which don't have on-chip storage, and this is something we need to address, but it's more work, I think, in the future roadmap. Yeah, but I think ITS is required as per the security certification requirement, but it has to be emulated on an external flash through some sort of rollback protection. Anyone else, or Andrea or Eric, if you have any follow-up questions?
Okay, well, I think we've come to the end of the scheduled time, so I can add the link for the Slack channel if anyone wants to continue this conversation. I'll add it to YouTube as well as Zoom here. Thank you, Shibu and David. That was great.
Thank you.
Hey, Paul, you should be able to unmute
Hi
now.
there.
Oh, there you are.
That looks good. Can you hear me and see me okay?
Yeah, I can hear and see you clearly.
Okay.
So whenever you're ready, you can...
And can you see the slides?
Yes, I can see the slides.
Excellent. So first of all, I want to invite everyone to join the Slack channel for this talk. I'll be keeping that open to see any questions. I probably won't follow the questions in Zoom or on YouTube. I'm not intending this to be the most perfectly scripted start to finish talk. So yeah, if you've got any questions, post them in Slack. I'll try and get to them. Thank you very much for joining me today. I'm going to talk to you about open source license compliance with Yocto project. So yeah, a little introduction about me. I've been involved in Yocto project since around 2013. I work across the whole embedded software stack, mostly sort of single board computers, helping out hardware vendors with their Yocto project support. I'm currently principal engineer at Consulco Group, providing those services to clients, and there's some contact information on this slide. So got to start with a bit of a disclaimer since we're talking about license compliance. Nothing I say in this talk is legal advice. What I'm trying to give you is best practices based on my experience as a developer, my experience as a member of open source communities. And if in any doubts on any of this, consult an appropriate lawyer. So this talk, I'm going to give a bit of an introduction, talk to you about license compliance, Yocto project, the tools that we've got, provide a bit of a brief overview for those who may not be very familiar with these tools. Then I'm going to look at a couple of sort of newer topics for us, which is the language package managers that have come along with new programming languages. I'm going to talk about SPDX and the tools can be used to generate SPDX documents. I'm going to talk about finish up with future work that can go on in this area. And as I say, I'll be taking questions on Slack during and after the talk. I did a previous talk on license compliance, very similar subject at ELCE in 2019. There's video and slides available for that. That's a bit more of a deep dive on the basic tools that we've got in Yocto project. I'm not going to duplicate all of that content today, so if you're interested, I highly recommend watching that and having a look at the slides. So yeah, the best place to start really is, why should you care about license compliance? Well, if you sell an embedded Linux device running embedded Linux, typically that's going to involve distribution of open source software that is physically present on the device. That carries a risk of legal action if you don't do it properly. So the right way to look at this is risk reduction. The other thing is, doing this well gives you standing and positive reputation within the open source community that can really help when you then want to influence those communities and participate. And the third thing I always say is, really you need to be keeping source code of all the third-party components that you use anyway to help with debugging, satisfy customer requests to rebuild something you did 6 months ago with one little patch. Sources do disappear from the internet, so you need to keep your own copies of this anyway. And once you've done that, you know, it's not too much of a leap from having all that source codes archived to being able to fulfill your license compliance needs. I also want to give a brief introduction to the Yocto project for anyone who isn't familiar with it. This is a toolkit for creating a fully customized embedded Linux distribution for your product. It's widely adopted. It's practically an industry standard at this stage. And we've got a really welcome and active community of developers. And yeah, there's several features that we've got that are specifically geared towards supporting license compliance. So, really brief example of a Yocto project recipe. So recipe is the thing that contains the metadata and the build commands for a particular piece of software. So this is just a recipe for a Hello World application. It shows the license. This format here is an SPDX license identifier. I'll mention a little more about SPDX later. It's just a standardized way of identifying a license. And we also call out a license file and the checksum of that file within the source tree. This just helps us to automatically notice if that license changes when you upgrade the software. So this metadata is kind of the starting point for license compliance activity. The metadata in public layers isn't always perfect, but it's usually in a pretty decent state. So once you've got these recipes and you're building software and building images from the recipes, first step to license compliance really is being able to provide the sources for components which are under copyleft licenses. And the Yocto project supports you to do this. We've got an archiver class that will collect the source code for any recipes that are built. Usually collect it in either sort of the original form as it would be distributed. Can also collect it with patches applied or after it's been configured. And this is all done by adding this line here to the local configuration file for your build. And then setting one of these archiver modes. The mirror archiver mode at the bottom is one I worked on over the last year, which is really geared towards producing a full mirror of all open source software, which can then be reused in future Yocto project builds. The archiver can also be tweaked and configured further to support your use case. So we support filtering which software packages you want to include the sources of, along with several other variables which are covered in the project documentation. The kind of other half to license compliance is providing the actual license text and copyright notices. This is often a requirement for permissive open source licenses as well as copyleft licenses. We collect all that license text as part of the artifacts produced by a build anyway, so you can simply copy this directory, but it will probably need a bit of post-processing to make sure you've got just the licenses that are actually relevant to your current build. If you're distributing a product and you want to include the license text in the actual file system image that's going to go on the product, we also support that in two different ways, really. One is by including this at the image generation time, and this just collects all the license text into one directory when the root file system image is created. The second is to create license packages for each software package. And this gives you an installable package and provides an upgrade path if you're doing sort of on-device upgrades using apt or yum or some other package manager. This provides you a way of getting the newer license text when you update a package. So a couple more tools that we have. We have the ability to exclude unwanted licenses from images. So if you're building something and for whatever reason you maybe don't want to include, I mean, GPL3 or later is kind of the go-to example that people use. But if there's a particular license which you want to make sure that no software covered by that license is included in your image, you can add that to this incompatible license variable within your build configuration. And that will then block the inclusion of packages which have that license. Typically, this applies to target packages only. That is, packages that are built for your embedded device that are going to go into the root file system. So this doesn't prevent things like a cross compiler or a development tool that's only used on your build host from being used. If you do exclude GPL3 licensed components, you may need to use the Meta GPL v2 layer to pick up older versions of some software packages. If that is the direction you go in, I highly recommend you contribute to the GPL v2 layer as well, because that really does rely on the people who are actually needing it and using it, helping to maintain it. And kind of to support this, what we do in all the core layers within Yocto projects and what we recommend in all of the layers is use the standardized license names from the SPDX license list to identify licenses. That avoids confusion. And it ensures that, you know, when you add something like GPL-3.0 to your incompatible license list, then that is the word that's used in the license variable for every recipe as well. The other thing that we've got is license flags. Sometimes this gets a little confused. What's license flags? License flags is a way of identifying recipes that have some additional terms beyond an open source software license. So this may be a commercial license or an end user license agreement that you have to agree to. It may be that the software uses patented algorithms, which may or may not be an issue for you depending on your use case, your jurisdiction, and other questions. So when license flags are set in a recipe, that results in the recipe being excluded from a build by default. And you need to come in and add those recipes to the license flags whitelist variable to enable those recipes. So this, in terms of open source components, you could see this for video and audio codecs. And it's useful for, say, flagging commercially licensed items as well. So one of the things we support within Yocto project is generation of a software development kit. And this is a self-contained build tool that you can give to application developers to let them build their code without needing to understand all the details of writing and maintaining Yocto project recipes. We've got two forms of the software development kit. We've got the plain SDK, and we've got an extensible SDK, which is kind of package based and allows you to upgrade the SDK on your developers' machines. The archiver that I mentioned before, that should capture the sources for any components that go into the SDK. So if you're distributing the SDK, you know, you want to treat that the same way you treat a routerfast that you're distributing and capture those sources. For the extensible SDK, things are a little bit different. I would highly recommend you do some research of your own there, because of the way the extensible SDK is built, there maybe is the opportunity for the archiver to miss things and some additional work required there. If your developers use the SDK to build software outside of Yocto project, that obviously bypasses all of our license compliance tooling. So do be careful distributing code that is built in that way. Just to jump back a little bit, where was the thing on GPL v2 layer? So Alexandre asked, do we know how well Meta GPL v2 is maintained regarding security fixes? I think I'm not sure off the top of my head. I imagine it's pretty much parked where the last GPL v2 release of a component was made, and if you need security fixes for that, that is a place where we would recommend you get involved and help us out with those things. So next topic I wanted to cover was license package managers. So this is something that's become a little more of an issue in recent years. So many newer programming languages use their own package managers. I mean, maybe not just newer ones. Python's always had its own language package manager. But for languages like Go, has the Go build tool. JavaScript, Node.js has the NPM Node package manager, and Rust has the Cargo build system and package manager. And these do present some issues for embedded development and for license compliance. You know, the concerns of embedded developers and the concerns of achieving license compliance just don't seem to be the things at the forefront of the developers' minds, the developers of these tools. And some of the features that I would say we need do seem to be missing from these tools. So the features we need to achieve this, from my point of view, is offline build support. It's very difficult to ensure that you've got an archive copy of all the sources you need and you've collected all the license text and everything else if the build process actually goes and interacts with online components and downloads additional components during the compile stage. We really need to be able to support offline builds as a baseline here. We need an automated way of downloading source archives for not just the package itself, but for all the dependencies. And that needs to include license text. It needs to include various collateral files, sort of readmes, installation instructions, and everything else within that source archive. We need to be able to support HTTP, HTTPS proxies. This maybe isn't a license compliance issue, but it's definitely an embedded cross-development thing to support people who are behind either corporate firewalls or national firewalls and may not have access to all the online services that some of us take for granted. The tools also should support source mirrors, so they should not be insistent on always fetching directly from a particular upstream canonical package manager website. You need to be able to provide your own mirror of those components, and that's important for testability. So to test that you've actually achieved license compliance and you've actually got all the source code, you want to rebuild just from your local mirror of that source code and see that it does actually work. And that will then show you that you've got a complete source archive for your image. So those are the features that you really need to look for when dealing with one of these language specific package managers. I want to sort of dive into one of these languages in particular, which is Rust. Rust is a language that came out of Mozilla research a few years back and has been growing in popularity in pretty much every area, including embedded software development. And it provides a lot of unique benefits and unique guarantees. So the Rust software written in Rust is built using a tool called Cargo. And Cargo is built both a build system and a language package manager for Rust. And so a Rust project typically includes a configuration file for the Cargo build tool. And this includes metadata, such as, a description of the software, the authors, the license, the other things you'd normally find in a Yocto project recipe as well to identify and describe your software. It includes a list of dependencies that are required in order to build an application or a library. And it includes configuration options for your piece of software. It could also include the configurations to set when building dependencies. And the Cargo build system is also associated with a software registry called crates.io. And this is a place where open source projects written in Rust can publish their source code. It provides search, it provides download functionality. So let's dive into Rust with Yocto project. Rust support is done by the Meta Rust layer right now. We're having a few discussions about bringing that into the Yocto project core, but right now it's in this Meta Rust layer. Because there's so much information in that Cargo configuration file, we can generate recipes automatically using this cargo-bitbake tool. And it seems to do a pretty good job of things. It includes source URI entries for all the dependencies of your project. Includes a fetcher that allows bitbake to go and fetch these dependencies, typically from crates.io. And it includes a Cargo class that describes how to build Rust projects. And this supports offline builds. It uses this bitbake fetcher to download all the crates you're depending on and does the build offline, which, as I say, is one of the key features we need. And this works pretty well with most of the Yocto project tooling that I've described. The archiver that I mentioned before supports HTTP proxies, it supports source mirrors. That all works pretty well. The one thing that is missing is those crate dependencies. The Cargo bitbake tool doesn't actually go and find the licenses that apply to all those dependencies and collect all the license text for those. So there's an additional step that we either need to add into the Cargo bitbake tool or that you need to be willing to do yourself when using software written in Rust. The next thing that I want to cover quickly is SPDX, which I have mentioned already. And SPDX describes itself as an open standard for communicating software bill of material information, including components, licenses, copyrights, security references. SPDX is supported in Yocto project by the Meta SPDX scanner layer. This layer provides tools to scan source code, to identify licenses, and to produce SPDX documents. That is essentially a software bill of material with all those licenses and copyright information in that document. The one thing I will say is generation of SPDX documents is typically a slow process because it involves scanning all the text files of your software to look for the licenses involved. It can extend build times by several hours. This is usable on a release build. When you do a release, it's not really usable on day-to-day development builds. But one thing we do support is scan code. So scan code toolkit does this job of looking through all your source files, identifying blocks that look like license text, and pulling out those license names into a big long list. So that is included as a class within Meta SPDX scanner layer. You can either enable it globally by adding that to local.conf Or you can just say inherit that class in the specific recipes where you want to do that license scanning, because obviously license scanning something as big as the kernel is going to be very, very time consuming, and you might not feel that you need to do that. Another component we can integrate with is Fossology, which is a much more fully featured system for license compliance scanning and for manual sign-off processes to confirm that you're happy with the results of the scan. Runs as a service with a web interface and an API. The SPDX scanner layer provides integration with this as well. I'm going to skip over this as I'm running out of time. And I'm going to wrap up with some future work. What I would like to see is better integration with those language package managers, which may require some extra features in the package managers themselves. I'd like to see automatic generation of a more user-friendly plain text or HTML license document for an image. There are other license compliance tools like the OSS review toolkit that we can integrate with. And I'd like to see some of these license scan and SPDX document generations tools used for our actual Yocto project releases, though that is non-trivial. And just a final link slide with some additional links that I've added after I published these slides online. So I've got a link to my Twitter and personal website and blog. Carlo's talk this morning was excellent. I highly recommend giving that a watch if you're interested in license compliance. He mentioned reuse.software, which is very interesting on this front. Within Yocto project, we've got a licensing mailing list if you want to discuss any of these topics. And if you're interested in licensing, I highly recommend looking at the Open Chain project. So thank you very much for that. I will be around on Slack to discuss further or answer any questions.
Thank you, Paul. I've just added the link to your Slack channel into the chat for anyone who wants it.
Thank you very much.
Hey, Cassidy.
Hi, Christine.
How are you?
I'm well. How are you doing?
Good. I'm ready for this right now. I'm sure everyone else is too.
I understand that. You guys have had a big day already.
Yeah, we've been online for I think 4 hours already. So, yeah.
I'm going to make this playlist shareable. See if I can, and then I'm going to drop it into the chat box in Zoom, if that's okay.
Perfect. Thanks. I have my mat behind me, so I'm ready. We also have this live stream to YouTube right now, so let's see.
Perfect. Okay. I hope I did this right.
30 people on there too. Yep, okay, I can see it. Oh, that went to all panelists, so I'll send it to everybody. Oops.
Oh, awesome.
Okay.
Thank you.
Welcome. I'll put it on the YouTube too. Oops.
Is the lighting okay in here?
Yep, I can see you clearly. Okay, cool. So let's just give it one more minute for anyone who might just be trickling in. Okay, I think we're good.
All
I'm
right.
gonna go on mute and turn my video off, so.
Okay. All right. Let's see. Try to figure this out here. Okay, hello. My name is Cassidy Holmes. We are going to be doing a 1-hour foundational yoga flow today. So I hope that you are in something comfortable and that you either have a blanket or a mat, something that can come in between you and your floor, just so that you can give yourself a space to practice on. Yeah, basically there really aren't many rules in yoga, but as much as you can, just honor your body. I always say that at the beginning of every single class. Honor your body. If I talk you into a pose that doesn't feel good, come out of it and maybe just do some deep breathing. But if you're new to yoga, this is really about connecting with the breath, calming the mind a little bit, and just giving yourself some time to be present and mindful. So I hope everyone can hear me. And Christine, let me know if you can't hear me. But I'm gonna hop on the mat. There's a playlist that the link has been connected to for Spotify, and it's the Linaro webinar 2020. Feel free to use that music if you'd like to have something that is going on in the background and helps you kind of sink into this practice. But feel free to not use music either. Just go in silence and listen to the breath. So I'm going to start back here on my mat, and go ahead and get onto your mat, blanket, whatever it is. And we're going to start in a child's pose. So bring your knees as wide as you would like. Invite the big toes to touch, and then you'll sit back on the heels. And once you do that, you'll just melt down over the knees, allowing the chest and the hands to crawl forward. And then eventually, either your chin or your forehead will meet the mat. And if that's not accessible for you, maybe you run around and grab a book or a block or a pillow to place underneath the hips. And so maybe you start to put that playlist on and find yourself in this child's pose, Balasana. And I'll just be demonstrating these poses for you and talking you into our relaxing practice today. So here in child's pose, here in Balasana, you might start to notice that your body's feeling some tension in the shoulders. Maybe the hips. And the biggest thing right now is to connect in with the breath, taking some deep breaths in through the nose, and some full breaths out through the mouth. So maybe you've been on here for the full 4 hours with this webinar. Your shoulders are really tight. Just take some deep breaths and try to release any extra tension that you might be holding. Maybe you find that you're holding some tension in the jaw. Just take some deep breaths in, deep breaths out, trying to release any of that tension you're holding. I'm just taking these few seconds, this moment to come to the space that you're going to be practicing in. And connect with that breath. And as you start to breathe, maybe you notice how the rib cage expands, how you're finding some space in between the shoulder blades, breathing into the back. With each inhale, the belly starts to expand. Deep belly breath, lungs will expand. With each exhale, the belly starts to fall inward towards the spine. We'll start to crawl the fingertips forward, bringing some movement into the body. Start to crawl the fingertips forward and feel that space in between the armpits, lengthening through the spine. We'll take a deep inhale to fill up with air. On the exhale, go ahead and walk the hands over to the left corner of the mat, or just slightly to the left, whatever feels good for the body. So just walking the fingertips over, finding a big side body stretch here on the right. And then maybe you release the forehead to the mat or to a pillow. And if I was there with you, I would be asking you to make this as comfortable as possible. So if you need to step off the mat and look around your space for some props, maybe just a pillow or a book. We'll breathe deeply into the right side, the right rib cage expanding. We'll take a deep inhale to walk the hands back to center. Crawl the fingertips forward just a bit. Full inhale, and then we'll walk the hands over to the right, finding that side body stretch on the left. Taking those deep inhales and exhales, allowing yourself to unwind. One more big breath here. Walk the hands back to center. Find that child's pose one more time. Release the forehead to the mat. Maybe rock side to side to give your forehead a little bit of a massage. Just letting your neck rock side to side. And then as slowly as possible, start to roll the spine all the way up into tabletop position. So in tabletop, you'll look exactly like a table. You'll stack your shoulders over the wrists and hips over the knees. Here, I like to have the fingertips spread wide, almost like you were going to high five someone. And from tabletop, you'll just gaze down towards the mat and take a deep breath in. On this inhale, you're still to dip the tummy towards the floor and roll the shoulders back. Lift the gaze. Just out in front of you gently. And as you exhale, you're going to start to arch the spine up towards the ceiling. Pull that belly up and in. And let the chin release. You're arching your spine like a scared cat would. And we'll move through these inhales and exhales into cat and cow. So here in cow pose, drop the belly, lift the gaze, shoulder blades draw towards one another. And arching that spine on an exhale. And if it feels good, tops of the feet can be rested flat onto the mat. If your knees are bothering you, maybe you're practicing on a hard surface, try to see if there's anything that can make it more comfortable. Sometimes I need to fold up a blanket. Maybe you close your eyes to bring yourself inward towards the body. We're just warming up after a long day of meetings for you. And then nobody can see you here. So maybe you start to get a little funky with these movements. Maybe start to create some C curves with your body if this is the first time you've done yoga. Starting to plug the right shoulder towards the right hip. Not actually doing it, it's just an image. And then left shoulder towards left hip. Just creating these little curves here in the side body. But then maybe you start to create some circles with the body, coming down towards the knees, crossing and circling over into the wrists. Maybe you've been typing all day and the wrists are really tight, fingertips are tight. And we'll come into neutral spine tabletop, taking a deep breath. And before we start to move any more into practice, we're just going to take a little wrist compass. I call it a wrist compass, just to bring some more space and stretching out into the wrists. So we're going to take the fingertips and we're going to point them towards the outer edges of the mat. So fingertips are pointing towards either edge of the mat. And then maybe you just start to rock back and forth into the left and right hand, bringing some weight into the meaty part of the hand. And then if it feels good, we'll move the fingertips so that they're pointing towards the knees. This is a big stretch. So listen to that body, listen to your wrists. If it doesn't feel good, don't do it. But the fingertips are dialed towards the direction of the knees and the back of the mat. And you can rock back and forth, bringing some space. And then go ahead and turn the fingertips back out towards the outer edges of the mat. We'll turn them forward. And then we'll bring the fingertips inward. So they'll be facing towards each other. Just rock back and forth. And then bring the palms nice and neutral, fingertips pointed towards the front of the mat. And we'll take a deep inhale, tuck the toes behind us, and just sit back, bending at the knees, sitting back on the heels. You'll find a huge opening in the soles of the feet. Go ahead and roll the shoulders up towards your ears, and then drop them down your back. Shoulder blades are starting to draw together. Chest is expanding. We're finding this big space with the collarbone. Maybe you close your eyes as your palms come towards your thighs. And just take a deep breath here. Let it go. One more big breath. Growing tall through the crown of the head, finding length in the spine. Letting it go on the exhale. As gracefully as you can, we'll make our way to an easy seat. So here in easy seat, you can cross left foot in front of the right. Just take notice, or right foot in front of the left, whatever feels natural for the body and feels good right now. But essentially, we're in crisscross applesauce. Sukhasana. So from here, you're going to ground into the sits bones. Maybe you need to remove some of that flesh underneath, wiggle your way into the mat. We'll take a deep breath, grow tall through the spine. And when I say that, I just mean to try to find some length. Try to stack your head over your heart over your hips. It's just a practice, so it doesn't have to be perfect. It's probably not going to be. That is the part of progress. Take a deep breath in. We'll sweep the fingertips up towards the sky. Maybe you lift your gaze. And as you exhale, we're going to float the hands down in front of us for a nice, gentle forward fold. And then you allow your chin to tuck in towards your heart. Take 3 deep breaths here. Notice that expansion. On that last inhale, maybe start to tense the fingertips and crawl your way back up to neutral spine. We'll start to roll the shoulders up towards the ears and then drop them down the back, taking some deep shoulder circles. Switching directions when you're ready. Again, rolling the shoulders up towards the ears, dropping them forward or backing down. Bringing some movement into these joints, waking them up. And then we'll start to drop the left ear towards the left shoulder, finding a big stretch here in the neck. And if it feels good, if you want a deeper stretch, you can take the right fingertips, right hand, and start to drop it on the outside of the right hip, straightening the arm. You should feel this long line of energy all the way from the crown of the head down through the right side of the neck, right fingertips. And just breathe into this deep stretch here. And as you're ready, if your neck needs a little bit of help, you can take this right hand. You can drape it over towards the left temple and just gently help your neck back up to neutral spine, floating the right ear over towards the right shoulder. So now you're finding this big stretch here on the left side. If you'd like to deepen the stretch, you can extend the left fingertips towards the outside of the left hip. Take 3 deep breaths. One more big breath in. Big breath out. You feel ready, take the left fingertips, maybe you drape it over towards the right temple, bring your neck back up to neutral. We'll take a few more shoulder rolls. Maybe you start to circle with the neck, finding some half circles here, and just drawing this sort of crescent moon with your chin. So you're bringing the chin down forward, finding some circles with the neck and the head. Releasing directions, or switching directions rather. And before you get too dizzy, bring yourself back up to neutral spine. We'll sweep the fingertips up overhead. Deep breath in. And as we exhale, we're going to open the hands out to the right, twisting at the core. So we're twisting at the navel. And as we open the hands out to the right, we're going to allow the left hand to fall towards the right knee. And then we'll gaze gently over the right shoulder And I'll turn around so you can see this, but the right fingertips will be tented behind you. So you're gazing beyond the right shoulder. Deep breath in, keep that length in the spine. And as you exhale, maybe you start to find that your right shoulder is tracking back just a little bit more. And in yoga, really, you can make this as deep as you want or as gentle as you want. Really, again, the only actual rule would be to honor your body, how it is after this day of being on the computer, learning so many new things. Stick with that breath. We'll inhale the arms back up to center, sweep them up overhead, take a full breath in. Get a little length through the fingertips, through the crown of the head, and then as you exhale, opening off to the left. Right hand's gonna find the left knee, left fingertips tented behind you. Keep that length in the spine. If it feels good for the neck, maybe you gaze off beyond the left shoulder. Just start to take some inventory of how your breath is. Your breath can tell you a lot about the way your body is feeling, about the way your body is holding tension. Maybe it's slow and steady. Maybe it's fast and rigid. You just take notice of it. We're not judging it, just letting it be. Few more deep breaths here. Growing tall through the crown of the head on that inhale. Maybe finding a little bit deeper of a twist on that exhale. Inhale, come back to center, sweep the fingertips up and overhead. And then we'll bring the hands down towards the knees and we'll just switch out the leg that was in front. So go ahead and uncross the legs. Just take notice of what leg was in front. Start to draw the fingertips up overhead one more time. We'll just take a few side body stretches here. So on the exhale, we're gonna drop the right hand off towards the right hip and we're going to reach over with the left fingertips. Now you can gaze down towards the right hand if that feels good for the neck, or you can rotate the nose up towards the sky. Maybe you gaze towards the sky, towards the ceiling. Maybe you can see the left bicep. Big breath in. Try not to collapse into this right shoulder. Just try to sit up and out. And inhale, come to center, sweep the fingertips up, let the left hand fall over on the exhale. Play with the position of the neck. Just become really good at listening to what your body needs. Again, notice if you're collapsing into this left shoulder. Inhale, come back up. And as you exhale, we're going to pull the palms out in front of us. So we're rounding the spine forward. I don't know if you can see this. Hopefully you can, so that I know the video's working. We're gonna take the palms and we're pressing them out in front of us, rounding the spine, dropping the chin towards the chest. And then keep the palms as they are and just grow tall through the crown of the head. You'll feel those shoulder blades start to plug back into the socket. Start to take the fingertips and spread them wide, all right? And we'll take our fingertips and we'll just start to rotate them out and then down. Big stretch here for the wrists. Again, maybe try to plug those shoulders in towards the socket. Almost like you're drawing the shoulder blades together. You're just stabilizing the shoulder here. And we'll just start to rotate the fingertips forward and then to the sides. Nice job. Maybe you just need to take a few circles here, releasing at the wrists. Again, maybe you draw the shoulders up towards the ears, taking those shoulder circles. Nice. And as you're ready, we'll start to bring the hands forward, and then we're crossing over the knees. So as you cross over the knees from easy seat into your tabletop, uncross the feet behind you, stack the shoulders over the wrists, hips over the knees. We'll spread the fingertips wide. And then imagine, again, you're keeping those palms nice and wide. You're going to rotate the fingertips just slightly towards the corners of the mat. So left fingertips towards the left corner, right fingertips towards the right corner. And then we're taking the index finger and the thumb and lining them up with the front edge of the mat. So almost you're creating an L. And from here, tuck the toes behind you. Just gaze down towards the mat, keeping a nice straight spine. Deep breath in, deep breath out. As you take another deep breath in, keeping the toes tucked, we'll press through the palms and gently lift the knees off of the mat for a hover. Big breath. And as you exhale, start to shift the hips, straighten the legs into down dog. So maybe this is your first down dog ever, or maybe your first down dog of the day. There's a couple of things here that you want to make sure that you're doing. If this is really tight on the hamstrings, you'll bend graciously into the knees. And as you bend into the knees, what'll happen is your heart will sink towards the thigh bone. So your heart's gonna sink towards your quads. Your heels are probably lifted off of the mat, and that's okay. As long as you're bending into the knees, this is going to be a big heart opener. And then maybe you just start to pedal the feet. You're pressing one heel down to the mat as you bend even deeper into the other. And it's quite literally you're pedaling. And you're finding this movement in the shoulders almost. So if this is your first down dog, connect back with that breath, because when we make our way into these poses, we forget to breathe. Yoga is all about the breath. And I might say some pretty cheesy things here in yoga class, but breath is the most important thing, not only in yoga, but in life. Breathe deeply. All right, finding this stretch here in the back of the legs. We'll take a deep breath in. And if you haven't yet, bend into the knees. And as you bend into the knees, lower the heart towards the thighs. Lift your gaze towards the front of your blanket mat. Take a deep breath in. And as you exhale, slowly walk your way, feet towards your hands. So you're walking to the front of the mat and you're hanging heavy on that exhale. So you're just allowing the head and neck to release down towards the mat. Your hips are going to be higher than your heart, maybe. Maybe they aren't. And then we'll walk the feet about hips width distance apart. So we'll heel toe the feet, hips width distance. And you can easily measure that with 2 fists in between the feet. That should keep, that's a good rule of thumb. And then you're just going to slowly lower the head and neck. Maybe you bend deeply into the knees, releasing the hamstrings. And then go ahead, bend the elbows, and grab opposite elbows. This is what we call ragdoll pose. Release the head and neck. Find a gentle sway back and forth. Connect with the breath. Big inhales. Bigger exhales. We'll release the hands down towards the mat. Start to walk the feet back together. Take a deep breath in. As you inhale, the hands are going to slide up the shins or towards the thighs, over the knees. And we're just gazing down towards the mat, flat back. Imagine that your shoulder blades are drawing together. Big breath in. As you exhale, release down into your forward fold. We'll do that one more time. Inhale, flat back, fingertips slide up the shins or towards the thighs. Gaze down a little bit in front of the feet. Full breath in. As you exhale, fold. On this last inhale, we're slowly going to bring the fingertips. They're going to start to touch the legs, dripping up the legs, and we're making our way into standing position. So you're rolling each vertebrae on top of another. Sorry, I kind of tripped over my words there. I'll move this computer screen so you can see. But we're rolling one vertebrae on top of each other, and eventually the head and shoulder is going to be the last thing that arrive. I think my head is kind of falling out of the view of the camera. And once you're here, start to draw the palms out towards the front of the mat. We're here into Tadasana pose, our mountain pose. And then you'll close your eyes for a minute, just to check in with yourself, take some inventory. How's your breath doing? How's your body feeling from gentle movements? Maybe you're a little out of balance, swaying back and forth between the right foot, left foot. Maybe you're finding some stillness. Whatever it is, just be there. We'll come back to the breath as we inhale, sweep the fingertips up overhead. And as you exhale, go ahead and box out the elbows. We'll bring them to a 90-degree angle, finding a big stretch here in the chest. Goalpost arms. Fill up with air. And let it go. One more big breath in. Let it go. As you inhale, draw the fingertips up towards the sky. And as you exhale, open the arms out to T, and we'll swan dive forward over the hips, over the knees, into a forward fold. Release everything once you're here. Just fold. We'll allow the hands to fall out towards the feet. Take a deep breath in for a flat back. And as you exhale, hands are gonna plant in front of the feet. We'll step back into a high plank. So in high plank, stack the shoulders over the wrists. And then just imagine that you're not allowing those hips to sink, just engage to the core and start to pull the hips as if they were neutral. Big breath in. And as you exhale, bend into the knees, drop them to the mat, untuck the toes, and we'll bend the elbows in towards the lower ribs, and we'll slowly lower all the way down onto the mat. So from here, create a little pillow for yourself with your forearms. I think I have to keep changing the position of this camera. That's okay though. All right, so creating a pillow for yourself with your forearms. We'll bring a bend into the knees, shining the soles of the feet up towards the sky, and then we'll windshield wiper the legs off to the side. So maybe with this pillow, you're gonna gaze off towards the left or the right, bringing one cheek to the forearms. And basically, you're just taking a shimmy shift with the hips, shifting the hips back and forth. And if you're gazing off to one side with the neck, go ahead and switch positions if you haven't already. We'll release the legs long, let them fall onto the mat. Start to stack the shoulders over the elbows, making your way into a Sphinx pose. So from here, you're going to lift the gaze, and you'll draw the shoulder blades back towards each other. You're just stacking the shoulders over the elbows. Hands are going to be flat on the ground. Maybe you close the eyes. Maybe you just softly gaze forward. Try to release any tension that you're holding in the glutes. I always do that. I always forget that I'm holding tension here. And it's pulling on the low back. And we'll just start to release all the way down to the mat. Start to plug the palms, pull the palms in towards the low ribs. So the elbows are going to be pointed towards the back side of the mat. Maybe your chin's resting on the mat here. But we'll take a deep breath in, and as you inhale, you'll slowly start to lift the chest off of the mat. Shoulders are rolling back towards the spine, so they're hugging the spine now. And then tuck the toes behind you. You're in this baby cobra, gently pressing into the palms, into the thumb knuckle and index finger. And with those toes tucked, we'll slowly start to push our way back into child's pose. So bend at the knees, draw the knees as wide as you would like, toes come to touch. Release the head and the heart down towards the mat. Connect back with that breath. Deep inhales, deep exhales. So maybe here in this child's pose, maybe you start to bring some sound into the breath. So if you'd like to create some sound with the breath and start to create some fire here, then imagine just like you were going to fog up a window. So you're bringing some constriction into the back of the throat on that inhale. And on that exhale, start to exhale through the nose, keeping that constriction. So this is your Ujjayi breath, your ocean sounding breath. And this action is literally like you were going to fog up a mirror or a piece of glass. That, and it comes from the back of the throat. Just inhale, constricting the throat. And as you exhale, keep that constriction. Imagine your navel floating back towards your spine. And it's just engaging the belly. As you inhale, let the belly expand. Breathe deeply into the low belly. And as you exhale, allow the navel to float in towards the spine. We'll start to inhale, roll the spine up to tabletop position. Scoot those hips over the knees, shoulders over the wrists. We'll take a deep breath in and we'll start to extend the left leg long on the mat. Toes are dialed down towards the mat. So finding this left leg nice and straight, take a deep breath in. Gaze towards the fingertips. And as you exhale, we'll bend the knee and we'll start to round the spine. So we're trying to draw this knee in towards the chest. Maybe start to point the just point the toes. You don't have to point the fingers because they're already planted on the mat. Round that spine. We'll inhale, extend the left leg behind us. Keep it nice and long. And as you exhale, bend the knee again, round the spine. And the chin can tuck towards the heart. And as gently as you can, we'll start to plant the left foot in between the hands. Perfect. There's really, that's kind of graceful, but it might not look graceful for you. And that's awesome. That's how it should be. So we'll take this right knee and tucking the toes behind you, just pick up the right knee, maybe start to shift it back a little bit, finding a deep stretch right here in the right hip, in this psoas muscle. That muscle gets really tight when you're on the computer. And then from here, bending into the left knee, tracking the knee over the ankle, gaze down towards the toes. And then if you'd like, tuck the right toes behind you. And we'll just start to pick the hands up towards the sky, sitting up out of that left hip socket. Imagine that the right hip is plugging forward, left hip is plugging back. And then you'll reach the fingertips up towards the sky, low lunge. Maybe you have a little wobble. I definitely do. It's okay to wobble. Big breath in. Rotate those pinkies in towards each other. Creates a spiral in the shoulder. That inner rotation of the tricep. Big breath in, fill up with air. And as you exhale, we'll start to goalpost those arms again, start to square off at the shoulders. Bend into the elbows, open through the chest. It's kind of a baby back bend here. So if you'd like to find an even deeper back bend, you can lift the gaze as you draw the energy forward with the hips. Inhale, extend the fingertips up towards the sky. And as you exhale, the hands will drape down to frame the foot. And we're going to straighten out through the left leg. You can walk these hands, fingertips back towards the right knee. And we'll press into the left foot. And maybe you bow towards the left toes, deepening the stretch here in the hamstring. Inhale to walk the fingertips forward, bend into the left knee. And we'll tuck the toes, the right toes behind us, lifting up off of the right knee. Walk the right hand towards the inside of the left foot. So you're in this lunge variation. Take a big breath in as you sweep the left fingertips forward. And then exhale, lift them up towards the sky. So now you're in a twisted lunge. Maybe you gaze towards the left thumb. Maybe you gaze down towards the right hand. Big breath in. Big breath out. Release the hands down towards the mat. The hands are going to frame the left foot. And then we'll gaze forward for a moment, just slightly, about a foot in front of the mat. And starting to just rock back and forth here on the pad of the right foot. Finding a slight rock in the wrists and the left knee. Gaze forward about a foot in front of you. Take a big breath of air. And as you exhale, maybe you step the right foot forward to meet the left and fold. Fold over the knees. Deep breath in, come to a flat back, neutral spine. Fingertips are sliding up the shins or towards the hips, towards the knees. Gaze out in front of you. Exhale, fold. We'll do that one more time. Inhale, flat spine. Exhale, hands frame the feet. Step back into your high plank. And just stay here for a moment. We'll bend the knees and lower into tabletop. Release the knees down towards the mat. Untuck the toes behind you. Gaze between the fingers, between the hands. As you inhale, start to extend the right leg long behind you. Toes are dialed down towards the mat. And you're pressing into the right foot. So it's a good way to ignite the sole of the foot and find a little lift here in the hip. Big breath in. And as you exhale, bend the knee around the spine. And just start to tuck the chin in towards the heart. Maybe start to point through the right toes. Inhale, extend the left leg or right leg long behind you. And as you exhale, bend the knee, pull it in towards the heart, rounding the spine. As gracefully as possible, start to draw the right foot in between the hands, setting up for low lunge here on this side. And then tuck the left toes. We'll pick up the left knee. We'll just slide it back a couple of inches, maybe just 1 inch, maybe not at all. Just listen to yourself. But we're finding this big stretch here, left psoas, opening up through the hip, stacking the right knee over the right ankle. Come to tented fingertips as you inhale to sweep up the fingertips towards the sky, lifting up out of that right hip. I have definitely forgotten my right from left these days. From here, we're plugging the right hip back into the socket as the left hip opens towards the front of the mat. Swivel those pinkies in towards each other, finding that rotation of the tricep. Fill up with air. And as you exhale, cactus the arms open. Maybe you find that baby back bend here, lifting the gaze. Whatever you do, just try not to bend deeper into the right knee. We really want to keep the right knee tracking over the right ankle. Coming up out of that hip instead of sinking into it. Full breath as you start to reach the fingertips towards the sky. And as you exhale, we'll float the hands down to frame the foot. Start to straighten out through the right leg, shining the sole of the foot towards the front of the mat. Your fingertips can track back towards the left knee. You fold over the right leg, right knee. Come back to the breath. Maybe you come back to that Ujjayi breath. Ocean breath. Sometimes I call it the foggy mirror breath because it's really the best explanation to use. We'll start to bend into the right knee, planting the foot firmly on the mat. Start to untuck the left toes behind you, picking up the left knee. Take a deep breath in, plant the left foot, or the left, guys, I'm really losing my mind over here. Plant the left hand on the inside of the right foot. Take a deep breath as you sweep the right fingertips forward. And then as you exhale, start to rotate the hand up towards the sky. Maybe lift the gaze towards the right thumb. Imagine that right hip plugging back into the socket, left hip plugging forward. On that exhale, release the right hand down towards the foot. Come to tented fingertips and we'll just shimmy shift back here, pedaling on the left toes now, finding the rock back and forth in the ankle, in the wrists. Gaze lifts about a foot in front of you. Big breath in. As you exhale, maybe step the left leg forward and fold. I like to bend into the knees here, especially with a big hip opener like that. Just starting to pedal into each knee, going back and forth. We'll take a deep breath in, slide the fingertips up the shins or to the thighs, flat back. Exhale, fold. On this next inhale, we'll make our way to standing. So roll one vertebrae at a time. Shoulders and head will be the last thing to arrive. Roll the shoulders back and down the spine. Palms are going to face out towards the front of the mat. Hopefully you can see me. And then close the eyes. Check in with yourself. Check in with the body and the breath. Quality of the breath. Just noticing. On that next inhale, sweep the fingertips up towards the sky. As you exhale, open the hands out to a T. Swan dive forward over the knees. Fold deeply. We'll release the hands towards the feet. Take a deep breath in for a flat back. On that exhale, hands are going to frame the feet. This time, we're just going to slowly bend into the knees and find our way bottoms to the mat. Start to straighten out through the legs. And just double check with the knees. Try not to lock them, hyperextend the knee. So we're extending the legs long. Take a deep breath as you grow tall through the spine. Keep that expansion happening across the shoulder blades, across the chest. We'll start to draw the right knee in towards the chest. Maybe rock it back and forth, just a little bit. And then we'll take the right foot, plant it on the outside of the left leg, left thigh. Taking a deep breath to sweep the fingertips up towards the sky. And then we're going to twist over to the right. Right fingertips tented behind the right hip. Left elbow draws towards the right knee. And then gaze gently over the right shoulder. Try to keep that length in the spine, not collapsing at the lower back. Engage the core to lift up and out of the hips a little bit more. There's a lot happening in this pose, in this gentle twist. Big breath in. Big breath out. As you start to rotate towards the center with your chest, we'll just start to turn off to the left side for a counter twist here. Maybe just bow over to the left hip just for a moment. And then we'll take the right foot, we'll cradle the right shin, and we'll just start to rock back and forth here. Just kind of picking it up. Rocking it back and forth, bringing some movement into that hip socket. Bend the knee, plug it in towards the chest, give it some love, and then release the leg long. Start to pedal out the legs. Again, nobody's watching you, so. All right, plugging the left knee in towards the chest. Big breath in. Big breath out. We'll take the left foot, drape it over the right side, the right leg. Fingertips sweep up towards the sky. If you know where you're going, get there slowly. We'll rotate the chest, the shoulders over to the left side, right knee toward, or right elbow towards the left knee. Gazing over the left shoulder. The most important thing here, keep that spine nice and strong, engaging through the core. I love tented fingertips for that left hand because it keeps you tall in the shoulders as well, instead of collapsing into that shoulder. And as always, breathe. We hold our breath so much throughout the day in stressful situations. We'll start to rotate forward. Hands are going to come off to the right hip, and we'll just bow towards the right hip, right side of the mat, counter pose. Go ahead and take this left leg, left foot, left shin. We're just going to cradle it a tiny bit. Just bring some movement into that hip socket. Before releasing the leg long, start to bring some movement into those knees. And then we'll tent the fingertips behind the glutes. Bring the feet towards the mat, soles of the feet towards the mat. And then just slowly start to walk your back down onto the mat. All right. We'll take one more pose here. We're running out of time for this hour. So if you need to get going, by all means, just take a second to take some deep breaths before going on with your day. But if you're here to the end, great. We'll set up for a bridge pose. So pointing the knees up towards the ceiling, draw the heels in towards the glutes. Fingertips are brushing down towards the heels. We'll take a deep breath in and a deep breath out. And as you inhale, start to press through the soles of your feet. This time we're gonna lift the hips up off of the mat. So we're pressing the hips towards the sky. We're tracking the knees towards the front of the mat, towards the toes. And then we're gonna walk the shoulder blades in towards each other. So the shoulder blades are hugging the spine. And maybe you find some more lift here in the hips. Maybe you clasp the fingers in towards each other, creating a little fist. Full breath in. Full breath out. One more big breath in to fill up. And as you exhale, unclasp the fingers if you have them. Slowly lower the glutes, the hips towards the mat. We'll just drop the knees side to side to create a little release here in the low back. And then we'll set up for our final pose here in yoga. You might have heard this before. It's called Shavasana, final resting pose. And the way to set up for it is releasing the right leg towards the right corner of the mat, left leg towards the left corner. Arms are draped down by the side and palms are flipped up towards the sky. But of course, you can make this as comfy as possible. If you're joining us for Shavasana, you can create a little bed for yourself by draping a blanket over the knees. Maybe bring a pillow towards the head. We're just finding a release here. Once you're set up, once you feel cozy, just come inward without changing the breath, without bringing any consciousness to it. Just let it be. Notice the quality of the breath. We'll take a little body scan before settling in. So scanning over the body, we'll start at the top of the head. We'll start to notice if we're holding any tension on the forehead or in the jaw. Maybe you bring a gentle smile to the lips to release in the forehead and the brow. We'll just imagine this wave of relaxation happening. It's drifting from the top of the head all the way down to the shoulders. And just start to release anything that you're holding at the shoulders. Release into the floor. Release down through the arms and the fingertips. Releasing through the belly and the hips. And then let your legs be heavy. Let the knees and the ankles be heavy. Releasing all the way through the toes. And if you haven't yet, let your eyes close. And as you find stillness in this resting pose, it's easy for the mind to start to create some chatter and try to pull your attention away from this. So if that's starting to happen to you, you can always come back to the breath, following that inhale and exhale. Knowing that those thoughts will be there afterward. Just give yourself this second, this moment to be mindful, to be quiet. And start to bring some movement into the fingertips and toes. If you've made it all the way here to Shavasana with us, start to wiggle those fingers and toes. Maybe you start to bring some movement into the neck by dropping the left ear towards the left shoulder, or left chin towards the left shoulder. And always switching directions. And then as you feel ready, start to bend the knees. And then we'll just drop off to one side. Dropping the knees off to one side. Rotating the heart with them. And creating a pillow for yourself with your bicep. With your forearm. And just taking a second, falling off to one side. And then slowly starting to move your way into a seat. Come into easy seat. Shuffle the tissue out from under the sits bones. Just let the shoulders fall down the back. Closing the eyes. Just taking one more moment, sealing in the practice. Just taking a second to send out some gratitude. Maybe you send out gratitude for a gentle yoga practice, or maybe for your breath, for something that's special to you. And with this gratitude, we'll just start to say thank you for everyone that's practicing with us. And even though it's not in a studio, this practice is happening around the world. So just send a second of gratitude out to the other yogis who have joined you, the other people who are taking care of their bodies right now. And we'll sweep the fingertips up towards the sky on an inhale. Palms can come to touch at the top. This is just a suggestion. We'll pull the palms into heart center and then press the thumb knuckles in towards the sternum, in towards the heart. Allow that chin to drop towards the heart, to find a big stretch in the back of the neck. Take a deep breath in. And as you exhale, we'll end class by bowing and saying namaste. Maybe lifting the thumb knuckles to third eye. Thank you for practicing. I hope you all have a lovely rest of your day. You can follow me on Instagram or on Spotify for some more yoga playlists. But I hope you enjoy the rest of your webinar week and you can remember some of these stretches.
Thank you so much, Cassidy. That was awesome.
Thanks, Christine. I hope you liked it.
I loved it. It was awesome. And there's a bunch of people still on with us, so.
Bye, guys.
Thanks everyone who stayed, and have a great day, everybody. And I'll see you soon, Cassidy.
You too. Bye.